All right. Hello. Number 14. Part 14. It's been a busy week. Um, this is only the second stream this week, and I'm quite sleepy. But we'll see what happens. I'm continuing to write a WebAssembly interpreter in Ruby. I'm doing it to have fun and to demystify WebAssembly and to share how I do it. I want to make sure I prioritize having fun over making something that is a complete implementation of the WebAssembly standard. I want something that's correct, even if it's not fast. I want something that's clear, even if it's not particularly clever. I'm trying to do it in pure Ruby. I'm trying to do it with no dependencies. That's what's happening here. Brief retro, as usual. Now that I've had a chance to think about how things went last time. So I managed to introduce an operand stack last time, which was really good, actually. I wasn't sure how much of a nightmare that was going to be. But it turned out to be not too hard to sort of wire it up gradually until it worked everywhere. So I was pretty pleased about that. I feel relieved that it wasn't too difficult to get working. So that was good. That's a little point of celebration, I think. Also, it turns out that there are essentially two syntaxes for writing WebAssembly, which I did not know. There are flat instruction lists and sort of hierarchical sort of prefix notation expressions, so in a tree. So it was kind of an unpleasant surprise to learn that, but I think we're dealing with that okay. Again, sort of bouncing back and forth between unfolding individual instructions and updating the evaluation of those instructions to be compatible with their unfolded form is sort of working okay. Oh, hi, Chris. Welcome. Yeah, who knew that this story was going to take such a dramatic turn? I mean, it's still really just one syntax, but it might as well be two because it's quite different. So yeah, that's going all right. Although I sort of had to stop halfway through, so that's where I'm going to pick back up today. Is kind of remind myself of how far I got with unfolding, how many of the instructions have already been unfolded, how many I need to unfold, and then I need to sort of finish that hand-over-hand refactoring operation by making it so that the evaluator actually evaluates unfolded expressions, those sort of flat lists. They're not flat at the moment, so I need to take a look at that to remind myself of how that works. So we'll do that in a sec. So I suppose the unifying theme of the things that went well last time is that I'm managing to make progress on potentially large and intimidating parts of this task by just making changes incrementally. With all of these kind of major infrastructural changes to how the interpreter works, I don't think I'd be capable of doing it, doing the whole change in one go. So this approach of sort of cutting over gradually and keeping the old code compatible while changing the new code, and then at the end when everything's working, sort of throwing the old code away is pretty cool, and I'm enjoying working that way. It's definitely satisfying to be able to avoid getting completely locked into earlier decisions or the absence of any conscious decision is just like what I hacked together at the time, by being able to kind of ratchet myself away from what I used to be doing into a different approach once I have more information about what it is that I want to be doing. So it's working out so far is what I'm trying to say. That's my retrospective, is that it seems to be working okay. No fatal problems. I mean, I'd like to keep working that way, keep sort of working incrementally and kind of chipping away and ratcheting up the accuracy of my implementation without any kind of big, punctuated equilibria of sort of, oh, now there's going to be a huge leap where everything changes. But I don't know whether that's always going to be possible. It might just be that I've been lucky until now, and like the next thing I try to implement is going to have to be like a huge change, and it's going to be painful, and I'm going to screw it up. So I mean, we'll see. Well, that's a bit of foreshadowing, I suppose, because speaking of that, it is now starting to really hurt that I don't have any representation of abstract syntax. I've managed to muddle through so far with operating directly on the raw S expression. Like to begin with, all I was trying to do was parse integers and like ambitiously add two integers together, and it was absolutely fine doing that on the raw S expression, and I just need a really simple parser to just chunk it up into to find the brackets and the white space basically. But now that I'm really getting into implementing the fiddly bits of the syntax, and there's more than one way to write an expression, and various bits are optional, and you get this sort of combinatorial explosion of like, well, this piece could be missing, or this piece, or they could both be missing. Or on this one's, this piece of syntax has a particular abbreviation. It's just getting very complicated. So. Basically, I can feel that I'm duplicating a lot of work because, well, I'm duplicating a lot of work and I'm making things more difficult for myself because I'm constantly having to deal with the idiosyncrasies of the concrete syntax in multiple places at the same time. So I think it's close to getting out of control and being more trouble than it's worth. Because I was trying to keep it simple and just work with the simplest thing that could possibly work, but I think I'm right. The needle is right on the edge of the red zone with that. So I think once I reach a stable point and I've got, this test or the next test or whatever all passing, I think I urgently need to prioritize introducing another parser that turns that raw S expression into something like properly structured for me to evaluate. So that's got like each instruction, including its immediate arguments, kind of coalesced into a single value rather than, each instruction is just an unknown number of adjacent atoms in the S expression. Oh, and maybe it contains a block, or, in the case of if expressions, they contain multiple blocks. Like it's too hard to deal with. So, I mean, I guess the upside is we're definitely going to need that abstract syntax in order to support the binary encoding of WebAssembly modules. So, when I was saying there were two different syntaxes for writing WebAssembly, that's not including the third syntax, which is just a sequence of, well, of course, everything is a sequence of bytes, but, like the binary representation rather than the human readable text representation. And like, if I ever want to stand a hope in hell of being able to execute that, I'm going to need to be able to parse that into some representation that I can execute. And not only would it be painful to translate it into an S expression, I also think I don't want to say it's impossible, but I think I need to synthesize a bunch of, because I think the translation from S expressions into the abstract syntax or into the binary form actually throws away like a lot of labels and things like that. So I would have to invent from whole cloth stuff just for the purposes of sticking it into the S expression. So I think it's fair to say that I have to have some kind of abstract syntax if I want to be able to support the binary format, which I do. So I'm going to have to do this anyway. It's not just a question of convenience, it's a question of necessity. So I might be able to get started on that abstract syntax today. Depends how far I get with all the unfolding business. And I suppose whatever other surprises the current test has in store for me. So, all right, let me press the buttons on my thingy. Okay. So here we go. Oh, I also wanted to briefly mention that Kevin Newton, while I was streaming last time, he tweeted and mentioned me. He was very kind and generous in his comments, but he wrote up this gist, I think, while I was streaming last time, because he had an idea about how you could use pattern matching to kind of dispatch across different types of thing that you might be working with. So I'm not going to go into detail on this. I just wanted to call it out and thank him for sharing this. The idea he's got is essentially to say, like, let's instead of just having a case where you're switching on the attribute, the value of some attribute or some key in a hash or whatever. I'll scroll straight to the punchline. The idea is that you can use the class to sort of match, so this the case equality operator on a class itself could be defined to check whether this class of thing is the kind of thing you want to operate on. And then you could have the constructor of this thing take that value as an argument, and then you could have, sort of polymorphically, you could have some kind of execute method on those classes. to do whatever the thing is that you were going to do inside all of these, the actual action you're doing inside the branches of the case. And then his punchline at the end is like, well, we could just monkey patch object or refine object to have this match method on it that allows you to just pass in several of these things, and it all kind of wires up nicely. So this is a really interesting idea. It's certainly nice and concise. It's very cute. I'm going to certainly bear this in mind, and I'm going to be thinking about whether there's an opportunity to use something like this in what I've implemented. I mean, right now I'm at this stage. I just have, I don't even have hashes. I just have arrays with strings in them. So I'm, baby steps at this point. But certainly if I get to the point where I've got abstract syntax, or I suppose what Kevin's suggesting here is that the underlying values are still just hashes, but you kind of wrap up the logic around recognizing them and processing them into some classes. Yeah, I'm definitely going to think about this. This might be a nice refactoring to do once I've got everything working. But thank you for that, Kevin. I really enjoyed reading this, and it's a really cool idea. So I'm grateful that you shared that. Thank you. So where are we? I have slightly forgotten where are we, but that's fine. We've got commits and stuff like that. I believe that where we are is that the this test, floatexplorers.wast, is not passing, but that's okay because it's pending. It's been, why don't I bring it up for a second? In fact, it's probably, yeah, there we go. Oh, no. So I obviously don't understand how Chrome works. Okay, so there are two problematic functions in this file that even though this is ostensibly about testing floats, the way that it tests the behavior of floats is by doing lots of control flow and things that I haven't properly implemented yet. So there are two problematic things. There's this calculate function. And I think the reason why this is problematic is because the body of it is multiple expressions. So this was something that I sort of did cobble together a fix for this at one point. I think in the process of unfolding some of those expressions, which I'll talk about in a second, this has become broken again. I mean, fortunately, it's inside this pending test, so it doesn't really matter. It would be nice to get it to the point where this is no longer broken, but clearly something's going wrong. It's so this local.setx f32 const local.set. So you can see this has been unfolded into one big long list of expressions, and we don't know how to execute that at the moment. So that's not working right. The reason I'm pausing is because I wonder if I could just fix that. I might be able to. Anyway, the other thing that's problematic is this tau function, and this is the real problem. This is just a long, undifferentiated, I mean, apart from with new lines, but those just get thrown away by the S expression parser. This is just a big soup of f64.const and then 0 and then local.set and then 1 and then block and then local.get. Let me just kill this person in the chat. They are now killed. And I have no way of executing this. So this is the thing that's blocking me. This is almost the last thing in the file. There's one more. There's a couple of assertions after this, but this looks fine. I don't see any problem with this code. I'm just trying to get to the point where I can successfully execute this. And the nature of the problem, just to recap, both for you, dear viewer, and for myself, is that the text format for WebAssembly In addition, as a syntactic abbreviation, instructions can be written as S expressions in folded form. So it turns out that all of the code we've seen up until now, everything except this tau function, is actually written in this folded form. So one way or another, we have to support, well, either, I suppose I didn't really talk about this explicitly, like either we have to support both syntaxes, you know, we have to support these executing these folded instructions directly and executing these unfolded instructions directly. And what unfolding means is, like in this case, this is a folded expression. Oh, it won't let me select the MathJax. That's a great user experience. So this is, oh, sorry, this is showing you, this is going in the opposite direction. So the bottom one is folded. So you can see this is a nice prefix. You know, you've got the operator first, and then you've got the operands, and it's sort of hierarchical. So it's like multiply together, add local.get i32 const2 and 3, and then the unfolded version of that is just a sequence of instructions where these first two are going to push something onto the stack, and then i32 is going to pop those two things and push the result, and then const is going to push something, and i32 mul is going to pop two things and push something. So we either have to support both of those syntaxes as sort of first-class citizens, or we need to be able to make one of them canonical and translate into it and execute that. And I didn't really say this explicitly before, but what I've decided to do is the latter. I've decided to treat these unfolded instructions as canonical. And I think that's the intention. I think the abstract syntax is like this. It doesn't have the sort of S expression structure. It is just an undifferentiated soup of instructions, a linear sequence of instructions, I should say, with a little bit of nesting for blocks. So I'm implementing unfold to kind of translate. Before we execute the instructions, we unfold them and execute the unfolded form. And that way we're sort of canonicalizing the syntax before we execute it. And like I said, it's very clumsy and there's a lot of repetition because I'm unfolding the S expression to make another S expression, and then I still have to execute that S expression. So this unfolding operation, for example, it needs to know that a block or a loop, for example, has an optional label and an optional block type before the instructions start. And when you unfold it, it's important that you keep the label and the block type there. I mean, that's actually not a great example, but maybe for maybe this is a better example for ifs. It's got an optional label on block type, and then it's got these instructions. When you unfold it, those instructions, this is the condition, they get moved in front of the if, but the label and the block type have to stay with the if because they're part of the if instruction, not part of this condition that has to go before it. And so that knowledge has to live both. I don't think I've actually done this yet, but that knowledge needs to live in the unfolding function, you know, the fact that this label and block type are optional and what they look like syntactically. And it also needs to live in the evaluator. So that's the kind of thing that I want to get rid of with abstract syntax, but I'm probably not going to get to that today. So I'll stop alluding to that. Chris Seta asks, is it a valid syntax to have the operations in an unfolded function be separated by spaces instead of new lines? That would look very odd. Yes, absolutely. So, I mean, as you can see here, you know, this is a valid expression. In fact, even these, my understanding is that when you look at the syntax of instructions, none of them have brackets around them. So here it says instructions are plain or they're block. If you look at all of the plain instructions, none of them have brackets around them. So basically and yeah, the white space is insignificant whether it's a space character or a new line character. So you can just write a one-line WebAssembly program that goes on for 10,000 characters without a new line in it. And you don't need to put any parentheses in at all, as far as I can tell. That might not be entirely true. Maybe some of these productions might involve, like maybe, you know, I think some of the type use might have brackets in it. Yeah, you see. So when you want to put in a type, you have to put brackets around it to sort of demark the beginning and the end of it. But overall instructions don't need parens around them. And then essentially when you get an instruction, if it has parentheses around it, that indicates that it's a folded instruction. So here, even in this one, the example they're giving here of the unfolded expression, it's not actually fully unfolded because here local.get $x is an instance of this first abbreviation. So this is abbreviating, you know, this is open bracket, the plain instruction is local.getX without brackets. There are 0 folded instructions after it, and then there's a close bracket, and then that gets unfolded to those 0 folded instructions, and then the plain instruction. So this here is an abbreviation for the exact same thing, minus the brackets. So you can even write this code as just local.get $x space i32.const space 2 space i32.add space. So that's the nature of the problem that we're trying to solve here. It definitely looks strange, and it's difficult to execute because you have to fetch the instruction, and then you have to, based on what instruction it is and how many immediate arguments it has, you have to decide how much more of the S expression to consume in order to create the full instruction. And yeah, my approach is that I'm unfolding it first before so here with this expression, before I even try to read these, I would unfold it into something like this, and then I would chomp through them. At least that's the plan. So what did I do? In fact, I forgot. I was thinking about this, and I wrote a little plan. So I did look through these and see what I'd been doing so far. So I've gone into unfolding instructions. So at the moment, let's have a look. Git log -l unfold. RB would be a more sensible thing there. Let's look at the reverse. No, okay, I can't put it there. So we started out with this dummy unfold function. I sort of dipped a toe in by unfolding just add. And then I've moved on to unfolding all the binary integer instructions, all the unary integer instructions, const load and store, and oh yeah, this was just a refactoring. I could clean up that huge long condition, and unfolding all the floating point instructions. Okay, so I've basically done all of the numeric instructions is where we're at. And as I'm implementing that unfolding, I'm also having to do corresponding changes in the evaluate method. So yeah, here now the evaluate method is if the first thing if we're trying to evaluate an expression and the very first thing in it is a folded instruction, is that what that means? Syntax is slightly weird. Oh yeah, because at the moment unfold is not actually making any effort to, although it's moving pieces of the instruction around. So here, if we find a load or a store or whatever, followed by some more expression, that expression gets moved in front and it gets unfolded, but we're not actually unwrapping the arrays here. So this, we're mapping over these remaining instructions, and so this thing here is going to be one big array. So at the moment it's not yet flattened out. But anyway, as I'm making these changes, I guess evaluate numeric is where those changes were actually visible. What is it? Evaluate numeric. Is it instruction or operation? Instruction. So yeah, here. So when I changed unfold to support unfolding const load and store, now here I've had to change load and store used to get these arguments, used to be followed by offset and value or by offset, and we would have to evaluate them ourselves. But now unfolding has shifted those. Well, they load and store. So they used to be followed by, in this case, one or two arguments. Now unfolding has moved those in front of them, so they get evaluated first and their results are left on the stack. So now we need to make sure that we don't try to match those arguments when we find the load and store instructions, and we can't evaluate them because we don't have them anymore. So that's the kind of the matching changes that I'm making there. So my plan was to carry on with this, keep unfolding more instructions. So I suggested here return local.set, local.t. So the plain instructions are the sort of the easy ones, essentially. Plain instructions, they all just follow this format where it's like, if i32.mul is a plain instruction, and if it's got some stuff after it, you just have to move all of that stuff before it, and then you stick i32.mul on the end. So that's essentially what I'm doing. Then we've got to look at unfolding structured instructions. So that's block, loop, and if. And these have got, unlike plain instructions that have just got a single rule, these have got special rules. Block and loop are basically the same, but we remove the brackets from around them, and we put this keyword end at the end. And then I guess when we execute this, we've got to keep executing the instructions inside the block until we reach this end atom. And then if is even more complicated because it's got this nested consequent and alternative, and it needs to be unfolded into this kind of flat list of instructions where you just say, the condition is moved out in front, so it gets evaluated first, and then if, and then these are the consequence, and then this is the alternative, and then there's the end. So yeah, it's going to be a little bit fiddly, but that's the plan. Consume the correct number of arguments during evaluation. So the idea there is if the evaluate function is able to, for every kind of instruction, to be able to pull the right amount of stuff off of the S expression. Like right now, it's just, we give it an expression and it just chews up. The first part is the instruction, and then everything else is arguments. But if we want this to be a big flat list of instructions, it needs to be able to take smaller bites than that of the right size to be able to chew its way through the list. So the prerequisite of that is to, without jumping to that point, make it so that all of this code here, instead of trying to just eat everything it's given, it only eats the correct number of arguments here. And then once that's working, I can go back to the unfold method and completely flatten the expressions as they're unfolded, and then inside evaluate, I can just make a while loop that keeps going round and round and chomping off, the first time round it's going to eat 2 instructions off the front, and then it's going to eat 3, and then it's going to eat 1, and then it's going to eat another 2 until it runs out of instructions. And then I think if I do all of that, this code I will be able to execute. So that's the theory, and hopefully I'm going to be able to get there today. So it's not a very detailed plan of action. Oh yeah, I also optimistically made a list of other tests which are related to things we have already implemented and therefore might work. So I just had a quick skim through. This was a very unscientific survey. I just literally scrolled through this list of things and I was like, oh, float misc. That sounds like a test that should probably pass. Like forward.wast. That doesn't sound like a test that should pass because I don't even know what forward is. But everything here was stuff that I remember that I vaguely implemented something to do with it. So I think it's unlikely that any of these will work, but it might be interesting to see if they don't work, then why? Like, is there a single thing that's blocking all of them from working, or do they all have different dependencies? And, I might want to, if I don't stop after float expres.wast and move on to the S expressions, the abstract syntax, then it might be an interesting exercise to just pick 1 or 2 of these and try and get them to pass. But yeah, that's a song of the future at this stage. So, float expres. So Chris is suggesting you can have a failing section on your runner that runs all the remaining tests after the passing and pending blocks and errors if any are passing. Oh, right. Okay. But isn't that the same as pending? Or is that different? Is it just different in our minds? It sounds like it would do the same thing as the pending block, right? But yeah, I mean, I suppose I'm suffering at the moment because all of these are not actually being executed. So maybe that's what you're suggesting, is that, you know, it would be good if these were right. Yeah, lets you just focus on one pending. Yeah, so that might be worth doing. Like, for example, I could suppress the output, right? So I could make it so that it doesn't spew any more stuff onto the terminal, but like it is quietly also checking that all of these are still failing, and so I might get a nice surprise. Yeah, that's let me add that to my list of things. Oh look, I already have this to do from last time, that's add an AST parser, but I feel like it's become more urgent since I wrote that. Add a failing section to test.sh that runs some all of the remaining tests, perhaps silently, and fails if any of them pass, so that we know if when we magically start passing any of the other tests. Zeta. Good idea, Chris. Thank you. I'm a little bit unsure why this is happening, and maybe it doesn't really matter. How do I unfold? So this is local.set. I mean, I'm not actually unfolding that yet. So is that why? I'm just not sure I understand why this failure is happening. I'm just going to very briefly investigate that, just because I'm curious. Let's do. I keep being tempted. Okay, everything's up to date. I keep being tempted to mess around with these tests, and I think that's probably a recipe for disaster, because I'll forget that I've done it because I'm not actually sitting in this Git repository all the time. So let's call this calculate.wast. I'm just going to take a copy of it, just because I want to briefly investigate what's going on there, if only so that I understand what's happening. Oh, is there another calculate there? What's going on? Yeah, okay, there's two of them. So let's just have a look. I won't spend more than a couple of minutes on this. I just want to convince myself that I understand what's going on. All right, so it's that first assertion that's failing. So I'm just going to do some puts debugging here and say, well, how about in here, tap do unfolded, puts pretty print. How does Ruby work? Expression, and then that's sort of unfolded to unfolded. So I'm just curious to see at what point do we get that. That's quite a lot of unfolding, isn't it? So let's just look at that calculate. So you know, for example, I would expect this expression. Oh, except we're not unfolding any of these things yet. What do we unfold? We don't unfold local.set or local.get. Yeah, those don't get unfolded. Const does. Div and mul and neg do. Local.get doesn't. So local.set is left alone. Yeah, I mean, this is... what's going on here is really very dodgy. So this is okay. Look, f32.mul get x get q is unfolded to, and like I said, it's not actually being unwrapped, so it's not actually being flattened, but this is saying get x get q and then multiply, so that's okay. But I guess it's here that there's a problem. So this div here is getting unfolded to, the div gets plonked on the end, and at the beginning we get local.get r. Yeah, I'm just not sure where this local.set has come from. Maybe it's... I mean, the reality is, I suppose actually, the reality is I don't know how to execute this. So I suppose that's actually the issue, is that this is, yeah, all right, that makes more sense. It's actually not my unfolding that's the problem. It's these expressions that are the problem, right? Because this is not so different from what we were looking at here. So although here tau is one big long flat list of instructions, although this is... local.set x, f32 const 156.25, and then local set r. Yeah, I suppose it's just that we can't execute. Yeah, I think in invoke function, we do this thing where we sort of unfold all of the parts of the body and then smush them all together. I remember thinking about whether this was the right thing to do, and it is the right thing to do, but because each part of the function body gets unfolded and they do get smushed together, it means we've got this situation where we've got one instruction here and then it's followed by another instruction. So yeah, maybe I jumped the gun a little bit in doing this flattening here. We're already in a situation where if this was just map, I think that the output would be yes. Yes, because that's what the evaluate is designed to do. It's designed to, this loop at the beginning, if it finds a sort of an unflattened function body, maybe I'll leave it like that then until I'm ready to flatten everything, because I actually kind of prefer the idea that, I'm sorry, I'm not being very articulate, but clearly what I was doing before was not working, or it had broken some code that was previously working. So I think maybe I just need to remember to change that back again later. Because without that flat map, we get all the way to tau, because the body of that calculate function doesn't all get smushed together. We leave these brackets alone, and so that this evaluate function that has just got this thing here that says, well, if the first thing is bracketed, then evaluate it, and then evaluate the rest of it, it's able to recursively chomp off those bracketed expressions from the beginning. So even though it's sort of wrong, what did I say about this? Let me just check that I'm not... what is this? Invoke function. Yeah, see, look. Change invoke function to evaluate the entire body at once after unfolding. I think this is the correct way to think about evaluating the body of a function. Yeah, the bad news is the evaluate method currently can't cope with it. The good news is the only tests that have multiple instructions in their body are failing tests, so we haven't actually broken anything important. So that's true, but I think I'm going to change this and say temporarily unflatten function bodies to keep them evaluating. So let's say this, hold on. It's this one, right? So let's say as explained in blah, this isn't the right behavior, but it does keep evaluate compatible with everything in floatexprs.wast up until tau, which is helpful to confirm that nothing is becoming more broken as I make changes. I'll need to remember to change this back again when we unflatten, or when we start flattening expressions during unfolding. Okay, all right, that's good. I'm glad I thought about that, because that's reheated some of the leftovers in my mind fridge, and now I kind of vaguely remember what it is we're doing and how it works. Okay, so the first job on my to-do list, I know I'm like 45 minutes in and I haven't really written any code yet. This is why it's taken me so long to get this damn thing done. Unfold remaining plain instructions. Okay, well, so that's going to mean making some changes here. So I'm going to put them in line. To do return local set local t br if select, and then that means that in here we're also going to have to fix this, this. Oh no, I've already done local.get, or is that on the cards as well? Yeah, I think so. I think when I said local.set and local.t, I forgot about local.get. Thanks past me. This is also a plain instruction. That's why I was like, hold on, that's a plain instruction right there. Okay, so those ones, not block, not loop, br if is plain, select is plain. Okay. And then if is decide. If is the most unplain instruction that there is. Okay, so okay, well, I can just take these one at a time. So return is like, I mean, I could write it separately, but I think it's like this. In that it doesn't. So yeah, just take a step back. What's going on in this function is that we're sort of, when we do the unfolding, because unfolding is basically this operation, is like, I'm an instruction and I'm followed by some arbitrary number of expressions. So here we go. I'm an instruction, I've got an arbitrary number of folded instructions after me. Now, the way that we, well, yes, the way that we unfold it is that we move all of those instructions in front of it, and then we stick this on the end. So that's what's going on here. So this is the simplest possible case here, where it's like the instruction stands alone. So this is something like i32 add, like it doesn't have any immediate arguments, whereas something like const does have an immediate argument. It doesn't, const doesn't consume anything from the operand stack actually, but it has this sort of inline argument, if you like, as part of the instruction itself. So things like i32 add, we can just take literally the rest of the instructions, we recursively unfold them to get the job done, and we prepend them to the instruction. But the job that this unfold method is doing is that it's discriminating between instructions like i32 add that don't have any immediate instructions, and things like i32.load, which does have this offset. So and you know, that's the only immediate instruction that all of these things, the immediate argument that all of these things have. These operations here have different arities, but their operands are on the stack. So we don't, from an unfolding perspective, we don't need to worry about that. They're going to be caught up in this star rest here, and they're just going to be however many there are, they're going to be stuck in front of it and they're going to be unfolded. And by the time evaluation reaches this instruction, the results of evaluating those arguments will already be on the stack. But this static offset has to be kept next to, i64.load in just the same way that the 3 here has to be kept next to the i32.const. So that's what's going with i32.const up here, is that we need to make sure that if it's got this immediate argument next to it, we keep it, here, this expression is just saying don't change anything, don't move anything in front of it. So as I'm adding support for these, I just need to, if they're simple and they're in the same category as some of these other things, which for example, I think return is in this category here. I'm just trying to think syntactically, is this okay? Yeah, I think so. So I think return is just like i32.add in that it doesn't take any immediate arguments. It just returns whatever value is on the stack. So I can just slot that in there. And then down here, I think I can just say, well, instead of it having a return expression, which I then evaluate, it doesn't have a return expression. And therefore I don't evaluate it. So at the moment, return does nothing. And I think I like to do some control flow effect. Like it does do something, it just doesn't. I was going to say it doesn't have any effect on the stack, and I don't think that's necessarily true. But at the moment, we haven't had to make pass a test that expects return to do anything on the stack. So that's return. Local.set, where does that live? So that's got so basically local.set has got, and local.t has got this single immediate argument name. Like the change we're going to make down here is that we're going to get rid of value and stop evaluating it. And because, previously what we were doing is we were pulling the value expression out of the source and then evaluating it and then popping the actual value off of the stack. But now we just have to do that pop. But we have to make sure that this name here, when we unfold, stays next to, and what I'm realizing is it's very like this, but it's not the same as this because this is designed to match specifically this static offset. So let's just make a new thing here that says if we've got local.set or local.t, I guess we're going to need to know which one it is. And then it takes a name argument. Well, and then we're expecting there to just be a value there, right? So if this is a folded expression, yeah, the reason why we've got a splat here, splat rest, is not because we're expecting there to be an arbitrary number of expressions. It's just that it's going to be either 1 or 2. Because for load, there's just the address of where you're loading it from. And for store, there's both the address and the value. Whereas here, we don't need a splat. We know that it's going to be this value. I'm just trying to work out whether this is, I might be unnecessary. There might be more cases than are necessary in here, but for now, I'm just going to try and keep it simple so that I can understand what's going on. So we want to unfold the value, and then that's going to get evaluated, and its result is going to end up on the stack. And then we need to leave the instruction and the name. Again, we're not actually flattening this yet. We're leaving this as like an instruction whose extent is marked by an array so that evaluate can keep evaluating it. I suppose I should be incrementally running this to see, because the plan is that every time I make one of these changes, it doesn't break anything. Evaluate float instruction const. No matching pattern error. Oh, that's not very good, is it? What have I done wrong? Oh, hold on. That was I'm sorry. That was the existing breakage. I'm not going to remove calculate.wast because I might need it. Okay. Sorry, I've got to keep my eye on the ball here. Of course it's failing. I just don't want it to fail sooner than this. So, okay, that's fine. That's fine. Phew. I was briefly very confused there, but again, my brain is slowly warming up. Okay, so I'm going to say that we have done local.set. I don't know why I went straight to that. Why didn't I do local.get? I suppose it's because I forgot it when I was making my list. Okay, so how does local.get work? That also just takes a name. Oh, rather, it takes a name, but not a value. So I think that means it's in the same category as these i32 consts and stuff like that. So I think when we evaluate this, when we unfold this, we don't actually change anything. So it's like this example here. This local.get here, when it gets unfolded, it just stays. I mean, ultimately, I'll be removing the brackets around it, but at the moment, I am indeed just leaving it alone. So I don't think that needs to change. Let's run the test. I realize I could be committing all of these separately, but I think this is a small enough change that if I can make a commit that's just like, you know, supporting unfolding for the few remaining plain instructions, I think that's fine. Okay, br if, how does that work? So this takes a label as an immediate argument, and then it's got this condition that it evaluates and then pops off the stack. So it's a label condition. I'm just going to add it. I think I can probably coalesce this with another, but maybe in terms of like making the commits clearer, maybe this is a little clearer. So I'm going to unfold the condition, and then we're going to evaluate the instruction with its label. Great. Okay, well that just leaves select. How does select work? Value 1, value 2, condition. Okay, so how does that work syntactically? I think all of those, I'm just going to check, but I can't search for select. This web page situation is not good. What is it? Parametric instruction? Yeah, select. Yeah, that's just a type, and clearly we haven't. At some point, we're going to have to support a type annotation on this select, but that's not mentioned here. Basically, select just stands on its own after it's been unfolded. So all of these, value 1, value 2, and condition, they all need to be evaluated on and sitting on the stack, which is exactly what we see here. I don't know why I looked at the spec. I can just read it off here, that we need all of these to be pre-evaluated so that they can be popped off the stack. So the way we're going to arrange for them to be pre-evaluated is by unfolding them and putting them in front of the select. Value 1, value 2 condition. Value 1, value 2 condition. I mean, this is just the same as this, isn't it? But I'm just writing them out individually. I'll do a commit in a minute to clean this up. So I think this is just like unfold value 1, unfold value 2, unfold condition, instruction. Oh, except instruction needs to be marked out. I think that's right. Let's just check. Oh, no, that's no good. Let's run the normal tests. So how does it look if I just put them value 1, value 2, value 3, map, unfold. Oh, it's not called value 3. So that's no good. Okay. That seems to be more correct. I didn't really think about what I want to happen here. I mean, like I say, I think I'm going to clean this up shortly. So I'm just going to, for now, okay, I'm going to get rid of calculate.west because that's not helpful. Okay. Well, yeah, I'm just I want to plow on. So as usual, I'm just going to leave a little bit of mess here and just keep going. I mean, I've been a bit inconsistent because I sort of stuck return in here because I realized it worked the same as these things. I think actually select probably works the same as these things, but whatevs. Let's just say unfold remaining plain instructions. Okay, so, all right. So now I've been slightly dreading this. Got to unfold the structured instructions. So those are block, loop, if. The reason I'm dreading it is because, well, as you can see, there are two. This has all got quite messy. For now, I'll just preserve the mess, but I just want to note that, like, as you can see here, block instructions have an optional label and an optional type. This block type thing has got a question mark after it, and ditto, the label, when you expand it, it can either be an identifier or it can be epsilon, which is the empty string. So the label and the block type are optional, and it's consistent for blocks, for loops, and for conditionals. But here I've sort of some organic evolution has happened here where for some reason I've needed to support labels for blocks. So I've got two different evaluation rules here for a block with a label or a block without a label. This one, it's not even trying to catch it. So obviously, whenever I introduced this, it was for an example that labeled its block, but that where you don't need to catch, where there's no like branch out of it, because that's what this catch is doing, is allowing the evaluation of the block's body to then branch out of it. So that's a bit of a mess. The loop can also have a label, but in this case, it's not being guarded by a regular expression. So this label doesn't have to start with $1. It could be literally anything. So if we ever have a loop that doesn't have a label, then the first instruction is going to be sucked in as the label. So that's bad. And then for some reason, if is at the bottom here. And it looks like if at the moment, oh, this is the type. So this thing here is the type. Again, it's not being treated as optional here. So, okay. So this is a bit of a dog's dinner. I think given that my goal right now is to get this test passing, I'm just going to continue to support what I already support. Because to keep all of the tests passing up until tau, I need to only support the cases that I've found in the test so far. And then there's obviously some cleanup needs to happen here where all three of these need to treat labels and types as optional instead of this weird, and I don't know what on earth is going on with this not being inside a catch block. Very concerning behavior by me there. So anyway, oh look here, I just realized the label. Oh yeah, here the label, there is no label and that's why it's catching a number. Okay, right. So I'm gonna reproduce this block loop if. I'm just gonna copy this up here so that I can refer to it. So I'm going to want, I suppose I can sort of paste this in. So I'll start underneath that stuff I've just done. I'm a little bit worried about making the changes on the oh, maybe it'll be okay actually. What I was going to say was I'm worried about making the changes on the evaluation side, but actually maybe it's fine because these ones don't actually change very much. All we need to do is just change the syntax. So rather than block expecting, well, whatever it expects, a label or a block type and then some instructions all the way to the end, we just need to make it expect the end keyword at the end. So actually it's not so bad. And similarly for if. So actually I think I've changed my mind. I think this is actually going to be quite straightforward. It's just because I've made such a dog's dinner of not implementing these consistently, I'm going to need a few different cases here to make it work. And I don't feel good about that. However, we can just read off what unfolding a block is. So if you've got a block, a label in this case, and then a body, that becomes, I'm going to keep with this pattern of matching the instruction into a local variable. So we repeat the instruction, and then in this case we do have a label, and then I guess I can just right, this is the same point I was making before, I think, or last time actually. What I was going to do is just unfold the body here, but I can't because this is not a folded, you can see here in the syntax of when you've got a folded if, the condition is a series of folded instructions. But here, well, in fact, in both cases, this applies. What my point is that I can't just say unfold body here, because body might be, well, basically, body doesn't have brackets around it. That's the short version. Body is a sequence of instructions here that's not surrounded by brackets. So I can't, for me to try and interpret it as a single folded instruction would be totally bogus. So I think I do have to map over it. So I have to do body.map unfold. And then I have to stick end on the end. I think that's right. And I don't think anyone's going to tell me whether that's right, but I'm actually very confused about. Oh, okay. Yes, I am confused because I thought here that body was splatted, but it's not. So this is clearly a case where somewhere I found an instruction where the block has got literally one expression as its body. So maybe I can just unfold it then, because it's not multiple expressions, it's just one. I mean, this really doesn't feel good. So with this one, I think it's going to be instructions map unfold end. So let me just try doing block for now. So this is going to be the same in both cases, but now it's going to have end on the end. And fortunately, Ruby pattern matching is fine with this. For me to say you've got a splat in between a known beginning and end, I don't think it's going to complain about that. Okay, that looks fine. Like I say, I feel pretty gross about this. And I suppose this is what I was talking about with the combinatorial explosion, is that I've got an explicit, I mean, this, I don't see any reason why this can't be, no, I'm just gonna keep it simple for now. I'm just literally gonna copy what I had in evaluate, but there's no reason why this can't be mapping over multiple things here. But if I wanted to have a version of this that's got a label but no type, and has got a type but no label, and has got a type and a label, and has got neither a type nor a label, I would need 4 different cases here. So I think I'm going to need a slightly smarter approach to dealing with optional stuff. Likewise here, the only reason there's not another case here for when the static offset is missing is because that's covered by, I think, the case below. So we'll fall through to the next one. If there's a load or a store that doesn't have a static offset, it'll be caught by this rule. So yeah, I need to do some thinking about what's the tidy way for me to deal with this. I suspect the answer is to change these expressions so that they're matching only the beginning. So to have something like this, and then inside here, to be able to say, like, you know, rest in, so in being a sort of optional pattern match, you know, so to do something like this where it's sort of allowing it to sort of optionally consume a label from the front of it. But again, I'll come back to that. I think for now, the simplicity of having what I'm adding here exactly match what's down in evaluate has actually got some value. no pun intended. So that's block done. Loop, pretty much the same deal, isn't it? This is going to expect to get end on the end. Again, mysteriously, there's always a label. Fine. There's probably only one loop that I've implemented so far. So that's going to be instruction. No, it's basically this, isn't it? Except there's a label this time. Is that right? Loop, label, instructions. Loop, label, instructions, end. Yeah. Okay, we all good? Yep, and I'll just start the full test suite running while I do the last bit just to make sure. So again, this is going to expect end token on the end. Oh, for this one, this is a little bit different because it evaluates its condition. Yeah, that's all good. So I think unfolding is going to move the condition in front of it. In fact, hold on. Let me think. This unfolding completely changes the structure of if. So if what we had was if, just ignore labels and types. So if we say like if, I don't know, i32 const 0, then i32.const 1, else i32.const 2. So that's folded. Unfolded looks like we move the condition out front. And then we say if, ignore label, ignore block type. And then we strip off the bracket and the then, and we just have the instruction sequence inside here. So this was i32.const 1, so that's the consequence. And then we do else, consequent, sorry. And then we've got i32 const 2 end. So sorry, I'm just trying to write this so that I can take a metaphorical step back from it and think about what I'm doing. Right, okay. So it is actually going to change. It's going to look like the condition is going away. We don't evaluate it anymore. We just pop it off the stack. So that's fine. So it starts with if, I guess we've got, wherever we've got an if, we've got this type. So I'll leave that for now. And then instead of having then and like nested then and consequent, we just have consequent. And then we do have an else keyword, and then, but it's not nested, and then alternative is just there, and then end. So I think that's what the unfolded, in fact, if I copy that, that'll be quite helpful, won't it? Because I want to do something like that here. I don't know why I've done this. Binding these local variables, it doesn't really make sense. Oh, okay, but except the condition has to come first. So folded instructions star. So does that mean I need to do condition.map unfold? Oh, and then the rest of it God, I keep nearly forgetting to do this. The rest of it I'm not flattening it yet. I'm leaving it marked off as being an expression. So if, and then we've got the result. Oh, I guess in previous expressions I've bound this as well. So and yeah, of course I can't just write result underscore. That's silly. So the instruction, then the type. Yes, and then if I sort of, I suppose implicit, again, I haven't really said this properly, but what I'm trying to do is not, this unfold method is not trying to apply this transformation just once at the top level. It's trying to apply it recursively all the way down through the S expression. So that's why I've got all these recursive calls of unfold, is because I just want to do a single pass over the whole tree and unfold everything. I don't want to unfold it one level deep. I want to unfold it all the way down. So the consequent needs to be unfolded. Again, should I be mapping? I was trying so hard to be pedantic about this, but now I can feel myself losing my grip on, like, I feel like I'm being inconsistent between the condition and the consequent here. Like, either I think I have to map over it. I should do the same thing in both cases. So the same thing here. I think. I'm very uncertain of myself there. Okay, well, that hasn't worked, has it? I mean, yeah, this is not feeling very principled. I'm just going to try. I'm just going to try this. If I was less sleepy, I think I would think a bit harder about what the correct thing to do is here. But I can feel myself losing my grip on what it is that the evaluate function is expecting to see here. It'll be, when everything's flattened out, it'll be much easier because I won't have to think about that. But because it's not flattened yet, it's really hard for me to keep track of where it's expecting to see nested arrays and where it's not expecting to see nested arrays. I mean, is there any consistency in what I'm doing here? Oh, yeah, okay, no. This is fine. Okay. Okay. It's all fine. It's perfectly principled. I completely understand what I'm doing. I don't need unit tests, Chris. It's totally fine. Yeah, it would help if I had. I mean, of course, as I've justified before, all these things I'm executing here are unit tests, but yeah, not very helpfully in this case. I don't have a unit test for unfold. However, let me just defend myself. The reason I was getting confused is because in the formal definition of unfolding here, all of these things are, this is multiple instructions, right? So the condition is multiple instructions, the consequent is multiple instructions, the alternative is multiple instructions. So that's why I was thinking I needed to map unfold over them. However, what I had missed is that, again, this specific implementation of if that I have so far built organically actually doesn't support multiple instructions in the condition or the consequent or the alternative. It only supports a single instruction. So that's why I'm not mapping unfold over them. It's because this should be splat condition and it should be splat consequent and splat alternative, but it isn't, because obviously I haven't needed to evaluate an expression that's got flattened multiple expressions in its condition or its consequent or its alternative. I can't. I'm losing the ability to name the parts of a conditional. So that's why I don't map over them. All right, that makes sense. That's totally fine. My brain still works. I still have a tenuous grasp on reality. It's all fine. Yeah, I mean, of course you're right, Chris. I should have unit tests for this. But it's working now. I think, yeah, I was thinking about this a little bit and thinking like, I'm now at the point where these tests that I'm running are driving through a lot of functionality. And so it does feel quite uncomfortable that I've basically only got acceptance tests for them, or I guess you could say integration tests. But certainly nobody is testing unfold in isolation, which is definitely a problem. But it's a private method, so you can't test it. So, sorry. And there's nothing that anyone can do about that. Unfold structured instructions, done. All right, well, I haven't actually made a commit, but... unfold structured instructions. I'm aware of at least 2 problems here. Number 1, exactly. Number 1, the implementations of block, loop, and if in evaluate are unnecessarily idiosyncratic. They don't, let's say, none of them support the general case of optional label and type and multiple expressions in various places. And 2, what was problem number 2? There is significant overlap between some, perhaps many, of the cases in unfold, which could be combined. For now, I'm making a conscious decision to keep charging forward to try to get the tests passing, but I'll come back and clean this all up soon. It doesn't feel great, but this is where we are in the year 2022. Okay. All right. So the next thing I've got written here is consume the correct number of arguments during evaluation. So evaluation is quite a large operation, which is at least broken out. Last time I broke it out into a few helpers. So I've got evaluate numeric instruction, evaluate integer instruction, evaluate float instruction. So actually, it's not by design, but I realize now that evaluate integer instruction and evaluate float instruction actually don't concern themselves with the contents of the expression overall. They're really just sort of auxiliary helpers that evaluate numeric instruction uses here, where evaluate numeric instruction deals with the expression directly, but then it matches out what it thinks it needs And if it's not a const or a load or a store, it just ignores what's in the expression. Because I think it's just used the instruction part. I think the arguments get ignored here. So we use them in these cases, but not in this case. Okay. So in that, I was thinking I was going to have to go bottom up from these. You know, these are the leaves. When I did some changes before, I sort of started at the leaves and worked my way back up to evaluate. But actually, these ones don't concern themselves with how many arguments. And I'm talking here about those sort of immediate arguments. Now that everything's been unfolded, I'm just thinking about consuming the right number of immediate arguments. Rather than assuming, maybe I should back up and recap what I'm trying to do here. The idea is that this expression, where I want to get to, where this to-do list is trying to get me to, is a place where I can support the expression being this kind of thing, where it's just a big, long, flat, undifferentiated list. So I need these functions that do evaluation. At the moment, they just assume that they're being given a single complete expression here. So here, you know, this is being given an instruction and all of its arguments. And then this case statement is like, match against that operation and all of its arguments. And then it'll only work if there are just two atoms in the S expression, const and the value. I want to try and modify this so that it's able to... Well, maybe the easiest way to explain it is to actually start doing it. What I'm thinking is, instead of here saying, oh, this expression definitely consists of an instruction and then that instruction's arguments, I want to be more gentle than that and say, well, the very first thing in this expression, you know, for me to have got here in the first place, we only call evaluate numeric instruction if this regular expression has matched the first thing in the expression. So we know already at this point that this first thing is a numeric instruction, but we don't know what the rest of the expression is. So this is what I want to do, is go through and make the whole thing more agnostic with respect to what comes after the thing that we're currently trying to deal with. So again, I suppose incrementally consuming its input, being incremental is very much a theme for this stream, I think. So this is all fine. This is just taking the instruction to pieces to understand whether it's an integer or a float instruction, and if so, how many bits. It is, because that's what this method does. But now here, I think what I'm going to do is, rather than say, I don't have arguments anymore. I just have the instruction, and consequently I have the operation which got matched out of it. So instead of matching on the whole thing, I'm just going to match on the operation. And so here, instead of matching a whole array, I'm just going to match const. So I'm trying to think how to do this consistently. I think I'm going to comment the old line out and put the new line underneath it. So... and then I think I'm going to have to do something here. Here, load, and here, store. Yes, this is the late night show. Sadly not a very good one, but we do what we can. Okay, so in all of these cases, so my to-do here is acknowledging that in all of these cases, what was previously referred to as value and splat memargs and, also splat memargs, is now going to be in this rest argument. And where I want to get to, there's no reason for me to do this at the moment, but where I want to get to is at the end of this whole thing, rather than returning nil, I want to return the unconsumed bits of the input. So my whole goal here, because I want to be able to call this from evaluate, and rather than have it just evaluate an instruction, I want it to evaluate it and then give me back, here's the unconsumed part of the, sorry, I'm dealing with the spam in the chat, return the unconsumed part of the input. So in all of these cases, I need to figure out how much more of the input for these three to-dos. I need to figure out how much more of the input do I need to consume. And in these cases, I was happily splatting away and saying like, oh, I'll just take all of it, please. But that's not going to work if the input's got 500 more instructions in it, because it's a big flat list. So, I mean, in the case of const, it's pretty easy to do, because I just need to say, I'm going to do it like this. I'm going to say, I'm going to take the rest and I'm going to pattern match it against value, and then I'm going to leave the rest. So this is going to pull rest in the same way as I pulled the instruction off of the front of the expression. Now I'm going to pull the value off of the rest of the expression, and then I'm reassigning whatever remains to rest, and then that will get, not right now, but ultimately I'm going to return that down here. I mean, maybe I will return it, even though no one's using it yet. I think that makes for a more self-contained change here. I'm trying to steer towards a commit that is just updating this function to consume the right amount of input, and I think that kind of feels fairly natural. So here, like I said, I was just splatting memargs and taking everything, but you can see here that all I'm hoping that memargs might be is a single item array here that contains a static offset. And I think the only other possibility is that it's empty. I don't know if there's any other kind of memargs actually, but obviously we haven't, I think there is actually, but I think that you can give it an alignment argument, but I haven't implemented that, so I don't have to worry about it. So I think what I'm going to do here is just, instead of, I don't even really need memargs, this can just be, I can match rest against, if the rest of the unconsumed input consists of a static offset, and then again I'm going to come in and say splat rest here, that will, essentially it's going to consume that static offset and it's going to reassign the rest local variable to be everything that comes afterwards. So I'm going to leave that alone, and then here I think I can do the same maneuver, because this is just duplicated code, so not great. Splat rest. Why is this local variable assignment here? I think that's just a mistake. Yeah, we don't need to reassign it here. It gets, I think I've sort of hoisted the assignment outside of the conditional and I forgot to delete it there, so I'm going to, oh, why don't I just add that separately? No, no, yes, no, no, yes. Remove unnecessary local variable assignments. I think I left these in by mistake when I refactored this code. So I think that's it. And like I said, down here, this doesn't touch the rest. These two things already have everything they need, because the operands come from the stack. They don't come from the source code, from the expressions. They're not immediate arguments in the way that the static offset and the const argument are. So I think that's it. Let's run the tests. Well, let's look at float expressions first. Oh, this is actually failing less badly now. Was it doing that before? No. So this is actually getting closer to parsing now. It's previously it was throwing an exception because it was trying to evaluate const for some reason. Somewhere down inside evaluate float instruction. Obviously something, I don't know what exactly had gone wrong here, but clearly something wasn't working right with those lists of unfolded instructions. But now it is actually evaluating to completion in some form or another. In fact, maybe this does explain it, that now that I've changed this to only consume what it actually needs, if there's more stuff in this expression, then now it's just going to get ignored, whereas previously it would have tried to include it in the pattern match it was doing. So maybe that's why it was failing. So this is, well, it's making it more robust to do things this way. Unfortunately, at the expense of there's now stuff in rest down here that is just being completely ignored, that nobody is trying to evaluate. But that's what I'm about to try to change. So yeah, this now, rather than expecting an expression that is a complete numeric instruction, instead it expects there to be a numeric instruction at the beginning of the expression. It consumes as much of it as it needs, and this is what I was talking about, sort of depending on the arity in terms of immediate instruction of the of immediate argument of the instruction that it's actually trying to execute. And then it will return the unused portion afterwards. And at the moment, we're not using that unused portion, but we will do shortly when I move up to the full, because I'm going to need to go through the full evaluate function and do this as well. But one of the clauses in the full evaluate function is evaluating a numeric instruction. So I need to take care of this before I can take care of all of those other cases. And this is where I do feel a little bit intimidated by the mechanics of consuming the right amount of input, because superficially it looks like it's not too difficult. It looks like, well, all you have to do, because this can be an arbitrary number of instructions, right? Superficially it looks like, well, all you have to do is just keep consuming more, sit in a loop or something, consume more instructions until you find this end atom, and then that's the end of your block. But unfortunately, it's not that simple, because one of these instructions could itself be a block. So the first end that we see as we iterate over this flat list of instructions. So if my expression was, block I32 const 1, I32 const 2, I32 const 3, block I32 const 4, end I32 const 5, end. I mean, I don't think I needed quite so many instructions to make my point. But the point is, this is the complete block instruction. But if I was to just start sitting in a loop and chomping these off and say, like, read the block instruction and then keep reading these atoms until you see one that's called end, then I would read that as being the block. And that is clearly not right, because that end does not belong to that block. It belongs to this one. So anyway, sorry, I'm getting ahead of myself, but I'm just trying to talk myself down off the edge of, like, this is not going to be quite so straightforward. I mean, it's just a parsing problem, and it's not a difficult one. You can just solve this with recursive descent. But all the more reason, like I said at the beginning, this should all be happening inside an AST parser. I should not be doing this inside the evaluate function. It's slightly ridiculous that I'm now having to insert a recursive descent parser into my evaluate function. But as long as all the moving parts exist and they work, I can rearrange the deck chairs on this ocean liner a little bit later on. Completely unsyncable, this WebAssembly interpreter. You can trust me. Okay, so what am I doing? I accidentally started thinking about the next thing I was going to do, and I forgot about the current thing I'm doing. Okay, right. Consume the correct number of arguments in evaluate numeric instruction. I'm returning the unused part of the expression rest at the end of the method because I know it's going to be needed further up in evaluate. Needed in evaluate, but it's not actually being used yet. Okay, well now let's do that. And like I said, I'm slightly worried about, well, actually, maybe I don't need to be worried because, well, there are several reasons why I don't need to be worried, and one of them is that it's not really anything to worry about, it's just programming. But the other thing is, there are plenty of other instructions that, like, there are just plain instructions here. So I think I'm going to deal with them first and get them working, again, in the spirit of sort of incremental ratcheting up towards a correct solution. I'll get the plain instructions working here, and then I'll take a breath and think about how I want to do the recursive descent parsing necessary to correctly read an entire block or an entire loop or an entire if from the input. And doing the plain instructions will help me to get the necessary infrastructure in place, by which I mean this no longer matches out all of the arguments, it's just matching the instruction, and then everything else is just the rest. And here we're not going to be matching the expression with all of its arguments because we don't know how many arguments it needs until we have checked out the instruction. So here, I mean, that's an easy win. Return doesn't have any arguments, that's fine. For local.get, it's just the same thing, I think. We want to pull name off the front of rest. And then we've got, I'm not even really thinking about what these implementations are doing. Why does this assign name? I really don't like that. Anyway, that's unnecessary. This is something for me to clean up later. I'm trying not to get distracted by if I get too distracted by like bad code, then I'm going to be here all flipping day. Okay, so I think that's right for local get. Local set or local t, I think it's the same deal. We just want to consume, we just want to consume the name. And then we're also popping the value off of the stack, so that's fine. Block, I'll come back to. Loop I'll come back to. BRIF expects a label. I mean, I think this is actually much simpler than I thought it was going to be. It's just a question of none of these have got anything complicated. Although I think the fact that I jumped over these is a bit naughty, isn't it? What I'm going to need to do here is I can't just ignore them because I've changed what I'm matching against in the case. So I think I'm going to have to sort of synthesize, I'm going to do the laziest possible thing here, which is just to recreate what is it? Instruction and then rest. Yeah. I know I could just use expression, but I want to pay lip service to using rest here. I realize that that's silly, but that's what I'm going to do apparently. Similarly here, instruction rest in this, and then this just becomes loop. So yeah, that's made a bit of a mockery of the whole concept of pattern matching, but I'm just trying to change as little as possible there. I think I did this one. Select looks like it's ready to go. It doesn't have any arguments. And then here I'm just going to have to do that same woeful case instruction rest, and then stick this in there. So yeah, my clever idea to just like ignore the difficult ones and not touch them hasn't worked out particularly well there, because I did in fact need to touch them. But let's just see. Oh yeah, and like, what am I doing with rest here? I suppose I'll do the same and make it so that if someone was calling this from the outside, they would get the unconsumed part of the input. But actually, what I'm going to want to do here is sit in a loop. I don't think I am going to return rest, but I think that having that there reminds, if I was to drop dead after this commit, which could happen, it makes it clear what this method is doing, which is you give it an expression, it consumes as much of it as it thinks is appropriate, and then it gives you what was left over afterwards. I suppose in these cases, it doesn't really. Is there a way that I can just, for argument's sake, can I just like stick a rest on the end? No, I don't think I can be bothered. Unless something's broken, I think I'm going to leave that as it is. Oh, something is broken. Syntax error. Oh yeah, because I put in on the end, even though that's wrong. Don't do things that are wrong. That's my Friday programming tip for you. And also, don't put more ends in than are necessary. But the thing about don't do things that are wrong is actually more important than the thing about ends. That was a bit... Okay, so everything's still working. That's good. I mean, I'm not trying to make any change to the visible semantics of these methods. I'm trying to leave them working and have them just consume exactly what they would previously have consumed from the input. So yeah, that's looking pretty hopeful. Yeah, it makes me realize actually that if I'd, I was hesitating over like, oh, can I just stick star rest on the end here? And I realized if I'd done that here, hopefully you can see what happens when I run the test, which is that this is now a find pattern, which firstly is experimental in Ruby 3.1. So I'll get not a deprecation warning, an experimental warning telling me I'm using an experimental feature. But more seriously than that, this is literally going to look for the first occurrence of end. When this was pinned to the end of the array, this will only ever match in final position. So my example here would work fine because it's only matching an end that appears literally in the last position in the array. However, if I make this into a find pattern, not only will I get a scary experimental warning from Ruby, but also now this star instructions will match as few of these as possible i.e. all of those instructions, so the end will match this thing, and then star rest will match i32 const for end. So I think not only is this scary, it's also wrong. Oh, and not only is it wrong, but that's not even a syntactically valid find expression, because I think you can't have the... So what I'd have to do is do this. Case rest, get rid of the block from the beginning, and then I'll probably get a warning, and then it will go wrong. Yeah, warning, find pattern is experimental, the behavior may change. Interestingly, it's a lot of warnings. Interestingly, it hasn't broken anything. Which is a bit embarrassing. But perhaps the reason for that is that there aren't any nested ifs, any nested blocks, which I can believe because I've only been trying to execute very simple tests up until this point. So perhaps that's just not exercised. But I'm pretty sure that what I said here is true. But, you know, as you can see, there are many problems here. So it's okay. We're in this it's this sort of transitional form where we're returning rest, even though it hasn't necessarily had the right amount of stuff consumed from it. So how on earth am I going to justify this in what could be my final commit message? Consume the correct number of arguments for plain instructions in evaluate. Is that similar to what I wrote before? Yes. I'm not yet able to deal with block, loop, and if because I haven't thought about it. So I'm leaving those alone in this commit. That means that the final rest array does not necessarily contain only the unused parts of the expression, because block, loop, and if currently don't reassign it after matching stuff, after consuming, after using elements from it. That's not a problem in practice because nobody is actually using REST yet, but I need to fix it before I can start using REST, i.e. in a loop that runs until REST is empty. Okay. I still, you know, dodging a lot of the actual detail of what's going on here, but at least it's a trail of breadcrumbs for the curious, I suppose. All right, so I think I'm going to use my tried and tested technique of wishful thinking and write the code that I wish I could write here. I mean, really, this whole thing is not fit for purpose. Or at least the block one, and the loop one I don't really know. But again, I'm just going to try to live with the mistakes of the past while I'm making this change. I'm just going to try and preserve what I've got, keep it working in the new infrastructure, and then I'll come back and fix up the many problems with this code, such as for some reason you can only have one expression in your body when you've got a label. So what I wish I could write on this end is something like, I wish I had a helper, foo, into which I could pass the whole expression. So this is this whole thing. So that's including, you know, e.g. block, you know, something like that. And what I want is for it to give me the bit that I want and the rest. So the job of foo would be to recursively find. Oh, and I guess here, you know, maybe there's a, you know, the bit that I recursively want is this bit, and then this would be left as the rest because it's not part of what is inside that block. So if I had that method, in fact, because this is a pattern match, in here I could just say, well, the bit that I want is going to be an expression that contains block and end, and in between there's going to be, what do I call it, body or instructions or something. You know, if I could do that, then I would have found, you know, this thing would be responsible for, I mean, what I'm saying is foo is just returns two results, right? It returns the complete nested expression, the block expression, and then it returns whatever it didn't consume as part of finding that. And then how do I plug this into what I've got here? Well, here it was called instructions. Maybe if I call this instructions. In this case, it's ready to go. You know, here, this literally is that block star instructions end. That is what this piece of code is expecting. Here it's expecting, I think what I want to say is if instructions is in this, so again, just leaving the existing semantics alone, this is really not what we want, but I'm just going to roll with it. So this is saying if those instructions consist of first a label and then a single instruction that is the body, then we're just going to evaluate it. I was about to run this and see if it works, but of course the small matter I'm overlooking is that I don't have a definition of foo. But I think this is what I want. That's the helper I want. And the reason why it needs to be a helper, well, it doesn't have to be. I could write it inline and make it iterative, but I want it to be recursive. I want to use the call stack to keep track of how many structured instructions deep am I. So let me just try and write that. where's the right place for that to go? I suppose I'll just put it as close as possible. So for now, actually, why don't I... Because I would actually quite like to be able to run this at some point. So I'll just put some comments here so that I remember that I'm trying to do these 3 cases. So foo here takes an expression, and what I want it to return is the instructions that constitute that expression, and then the rest. We can assume that the expression is going to begin with the block keyword, and well, that's consuming the block keyword from the front of the expression. Now, I think what I want to do is I want to say until expression starts with end, and at that point, whatever is after end is the rest. So we're going to have a loop in here that is going to try to eat enough of expression that the next thing in it is end. But crucially, the way we're going to do that is by recursively calling foo whenever we find another hold on. What I mean here is rest. What I mean is, yeah, I guess I need to make a decision about whether this match is just going to update expression continuously, or if we're going to leave expression alone and hold on to rest. I think I'm going to do the rest thing. I just need to be consistent, obviously. So rest is the thing that's going to start getting smaller and smaller, and then we just finally return what it is. I'm going to leave expression alone. That is the argument, and it doesn't get touched. So what I'm going to say is say case rest in block, do I care about what comes after it? I don't think so. I think I just want to know whether the first thing is block, because if it is, then I can call foo again, and I get something, and then I get what's left. So this is eaten, assuming, by the induction hypothesis here, if foo is working correctly, then this is going to eat a full block and then give me what's left afterwards. I'm conscious that this instructions doesn't exist yet, but I'm just thinking about making sure that rest has the right value here. So if it's found a block, then consume it. Otherwise, well, I guess it's not else. It's like in something rest. And then that just skips over whatever we found there. So it throws away the first item of it, essentially. So I think that's right with respect to the contents of rest, but now I just need to make sure that we initialize instructions to be empty, and then I'll set that's sort of set up at the top of the method, isn't it? And then here, the problem is I want to call this instructions, but that I can't. I'll call it expression because this is something I haven't really wrestled with, but expressions are written as instruction sequences. This kind of feeds into my, confusion over what's the difference between an instruction and an operation and an expression and a body and a label and an ID and a name and all of that kind of stuff. It's like expression is essentially a synonym for multiple instruction or for instruction sequence. And I think that's what I mean here. This foo is going to return an instruction sequence, which I will call expression. And then having got that instruction sequence, I'm going to concatenate it onto the end of that instructions array. So if what I get here is, if expression is 5, if it's like block, iconst 32.1 end, then that will all get shoveled onto the instructions array. Otherwise, in this case, this here is de facto just a single instruction, or it will be once everything is all flattened out. So that just needs to be shoveled onto the end like that. So I think that's what I want my foo to do. Does that work? I mean, the main problem I can see with this is that ends don't appear only in this thing here that's looking for ends. This catches ends. This is going to consume any ends that appear inside blocks, inside nested blocks, but it's not going to catch any ends that appear inside loops or ifs. So I think, well, I'll run it, but I think that to make this work, I'm going to have to put loop and I'm going to have to put loop and if in there as well so that it works, so that it skips over all structured instructions. Again, whether I even have a test that has one structured instruction inside another, I really don't know. It's looking promising so far. Yes, okay, well, I don't know exactly what's gone wrong there, but this does look like an expression where we've got a loop. I can't see where the block is in the original expression, but there clearly is a block as well. So I expect that this is a loop that's inside a block, and that's had exactly the problem that I mentioned. But let's make this block or loop or if, and then I'll need to do the same thing up here in that case. Oh, also, the instructions I'm returning here, when I called foo up there, I was assuming that you'd get block and then all the instructions inside it and then end. I'm not sure whether that's really what I want, but that's what I wrote up here, was like hoping that it was just gonna, I think this is the clearest thing, right? Is like, this is basically just a split operation that's just like split off the first structured instruction you can find verbatim and then everything else. But my instructions here doesn't include the block, the loop, or the if, and it also doesn't include the end. So that kind of feels like a problem. Well, that was actually, it got all the way to floatexpres.wast, so that's interesting. Okay. Well, this is still not working, so maybe actually what I just said was the problem. Maybe it's this. So I think instructions will need to start out having the instruction on it, and it will need to finish up having end on it. Again, all of this parsing rubbish shouldn't really be living inside here, but this is where it has to go for the moment because we're operating on the raw S expression. So that's a less horrible error. Exit does not respond to deconstruct. Oh, that's interesting. Invoke run. So it looks like the very first time so this is supposed to be a block that's got a label and then a single item in its body. So it's supposed to be covered by this case here. Hold on. There's supposed to be an else in here. Where did that go? This is supposed to be a... I was like, why do we evaluate the body and then we go into a catch here? I don't know what happened here. Maybe that was just a text editing snafu. But I think that's what's going wrong there, is that it's trying to... Yeah, it's trying to evaluate these instructions, the first of which is a label. So in this case, the label has been removed from that body, but then down here, it actually tries to evaluate it directly. So that is not right. Okay, good. So I'm glad that I'm not completely just ignoring the errors in this test that was already failing, because like it feels like trying to keep it holding on the same failure or better is actually helping me to catch problems in a way that I wasn't entirely anticipating. So that works. Therefore, I should be able to do the same thing in loop. So what does that look like for loop? I need to... Same kind of deal, right? But this time I'm going to get loop instructions end rest. Now, this was just administrative. Oh, so this is expecting there to be a label always, which is clearly not wise, but I can just bake that expectation directly into this pattern match here. So that's what this was doing. And then I think this can just stay the same. Yeah, that was surprisingly uneventful. Great. Okay. So yeah, this one turned out to be a little bit easier. This is one I'm really dreading. If. How's this going to work? Yeah, I'm not sure it is going to actually. So I can certainly start off with the same situation. It's just like this. If instructions end. But the problem is, well, in this case, I suppose there isn't very much of a problem, because what I was going to say was we need to not only match the end here, but we need to, it's the same kind of problem again. We need to find the else. Yeah, once it's been unfolded like this, if what was actually inside here is another if I32 const 1, well, let's say if else end, then the foo method will not get confused by this nested end, because when it calls itself recursively, upon discovering this if, it will identify that as a single structured instruction. So it will correctly identify this as being the outermost structured instruction, which is what we need. But then we've got the same shape of problem again, finding the appropriate else. Because if I just try to find the first else inside this structured instruction, it will be this one. But this else does not belong to this if, it belongs to this one. So I need some other kind of helper to locate the if, to locate the else. Now, actually, in this case, it doesn't matter, because apparently, so far, we only support a single consequent and a single alternative. So maybe that's fine. I mean, it feels like that approach is not going to be long for this world, if I'm honest. Because the very next thing I want to do is flatten out these expressions, which maybe the reason why this is working is because they're currently, they haven't been flattened out into multiple instructions. So this might contain multiple instructions, but they'll be inside an array at the moment. But that's not going to hold up as soon as I do the flattening. But for now, maybe this will work fine. I think it will, actually, given that the previous implementation worked fine. So that seems, I'll leave that running, but it seems promising. I suppose the most important question is, what shall I call this method? It's probably not foo. How about consume structured instruction? Is that what they're called? Structured instructions? Something like that. Yeah, plain and structured instructions. So, I mean, really what it is parse structured instruction, but I think it will just be too confusing for me to call it that. Like extract structured instruction? No, I think consume is fine. Okay. I didn't make any silly typos in that substitution, did I? Okay. I think that's all right. Like I say, there's clearly a ticking time bomb here with respect to if. But when the time comes, and I suspect it's coming very soon, I'll just need to define another method like this, but one that looks for else instead of end, basically. And instead of returning instructions and rest, it needs to return the consequent and the alternative, having recursively consumed any structured instructions, including ifs, that it finds inside the consequent and the alternative, so that we don't get confused about the else's. But it looks like I don't need that yet. I think I'm going to add this separately because it gives me an opportunity to just explain what it does. Okay. I mean, that's not very explanatory, is it? We need this method to recursively consume an entire block, loop, or if instruction in the evaluate method. So that we can correctly attribute each end atom to its matching block, loop, if, even when those constructs are nested. I'm concerned that this method will not be enough to consume an if instruction, because those instructions have the same nesting problem with the else atom, but for now we apparently don't have any if instructions with multiple instructions inside their consequent or alternative, so it's not a problem yet. It presumably will be once we flatten the unfolded expressions. Okay, that's what I wanted to say, really. Okay, and then this is me just wiring it into consume, what did I say? Consume the correct number of arguments for structured instructions in evaluate. As the previous commit explained, I don't think this is correct for if in general, but it's working at the moment because we haven't flattened the unfolded expressions. Okay. So how far have I got through my to-do list here? Consume the correct number of arguments during evaluation. I mean, for now, I think I have done that. I mean, I think I might have to come back and untick this after I flatten the expressions, because if it blows up when I flatten the if, then I know I've got a problem. But I think so far, I seem to be doing this okay. And I mean, I guess I've got a choice about what order I do these things in. Or do I? Oh, well, I could do this. Okay, so the assumption is, and I think this assumption is correct, that at the moment, at the end of evaluate here, this method, and at the end of evaluate numeric instruction, this method, I think rest is empty. So let's try raise unless rest is empty. So if I did put a, assuming I haven't screwed anything up, then even if I did do that, put a loop inside evaluate so it can keep consuming things, I think all this sort of semantic preserving transformation I did here that was to meticulously consume only exactly the instructions that were needed from the expression, at the moment that should be all of them. Like, if there's a situation where we haven't consumed all of them, then I might have made a mistake here. So that's a long-winded way of saying there's no point putting a loop inside evaluate because there's nothing for it to do yet. One pass through will. Oh look, it didn't take very long for that to fail, did it? Okay. Okay. Rest inspect. Oh, bad dude. Interesting. That sounds like an argument to const. Oh, look, I forgot to do something, which is I forgot to hook up the return value of evaluate numeric instruction. The whole point of this returning something is to update the value of rest, but I forgot to do that. So actually, I'm glad I did that sense check because that's important. If evaluate numeric instruction consumes some of the input, then we need to know that that part of the input has been consumed. Oh, phew. Ooh, that was a little frightening. I thought I had a much more serious problem than that. If I was going to try and turn this into a teachable moment, I would say this demonstrates the value of checking your assumptions because I was so smug that assertion was going to pass all the way through, and it never occurred to me that I might have made a rudimentary error, but of course I did. Okay, so now we are getting a unhandled exception in evaluate numeric instruction. So I think this is okay because this is symptomatic of why we've had this failure in the first place, right? Is because tau is the first situation we've ever been in where actually when we consume, what we're able to execute, there's more. And we haven't had that before. So I'm pretty sure that if I get that raise to report what the value of rest is, that I was saying it should be empty, I think the value of rest should be all of the rest of this body. So it's successfully executed this one instruction, and then all the rest of the body should be in rest. So let's raise rest inspect. Oh no, it's in float. I'm not going to wait for that again. Yes, there we go. Local set 1, block, local get 0. So yeah, there's the whole thing. So I'm just trying to work out whether I'm wrong or not about it being pointless to put a loop inside it. Oh, yeah, okay. It's not so much that it's pointless. It's that it's incompatible with this. So at the moment, okay, right. I understand what's going on here. It might not seem that way, but I do have a glimmer of understanding, which is that this piece of code here is what is shimming. It's correcting the impedance mismatch with what unfold is doing. So unfold does all the nice unfolding, but it doesn't flatten it out into a linear sequence of instructions because our evaluate function does not know how to deal with that, or previously it didn't know how to deal with that. It actually could deal with it now because we could just put a loop in here that says keep doing this, expression goes into instruction and then rest until rest is exhausted. And that would be fine. But the problem is we can't, the only instruction sequence we've got that's in the correct format for that style of execution is the body of tau. So it would execute this function perfectly if we changed it to work that way, but unfortunately it wouldn't be able to execute any of these other expressions that are all folded, and even when they get unfolded, they don't get flattened down into an unstructured sequence of instructions like this, which is what the loop I'm talking about would be designed to consume. So the order of instructions here, actually, the order of operations, is correct. I don't think I realized it was correct when I wrote this to-do list. It was just I had to write them in a linear order, and I picked this one arbitrarily, but 50-50 chance I actually got them in the right order, because before I can stick that infinite loop in here, I have to deal with this. I have to make it so that flattening produces code like this, not code that looks like this, except every single one of these is inside a pair of brackets, so that this line here that says, oh, just pop off the first element of this array, which itself has got brackets around it. So I've got to fix up the unfolding, basically, is what I'm trying to say. And so what that's going to do, I believe, well, I think we have to do both these changes at once. Sorry, I keep going back and forth on what I believe the truth to be here, but I think as soon as I flatten the expressions during unfolding, this code won't work anymore. It won't ever find this nested array at the beginning, because all of the instructions will have been not only unfolded but also flattened down. So it's not going to find any nesting like this. You know, in this sequence of instructions, there is no nesting, even though some white space makes it look like there is. But from an S expression point of view, this is just a completely flat list. There's nesting semantically in terms of the pairing of structured instructions with their terminators here, but not as far as this pattern match is concerned. So as soon as I flatten them, this will stop working, but I think I'm going to have to switch over to the sort of tau compatible interpreter. So I'm going to need to put a loop in here that repeatedly does this and evaluate and runs the whole body of evaluate, and then just keeps doing that until it's drained all of the instructions out. So I can't see any way to... I was sort of hoping that what I could do was just change the behavior of unfold and keep it compatible with what's already in evaluate, but I don't think I can. I think this is the final stage where I'm going to flip two switches together and the whole thing goes from being in one mode on the producer and the consumer to being in a different mode also on the producer and on the consumer, and I can't flip one switch without flipping the other, because then the producer and the consumer won't be compatible anymore. So that's a little bit unfortunate, because it would have been nice to cut this over slightly more gradually than that, but it's okay. So concretely, what I'm going to do here is basically everywhere that I'm making a nested array, I'm going to not do that. I'm going to make it so that when you call unfold with an expression, what you get back is a completely flat, it still has to be an array because Ruby doesn't let you return, you can't return multiple values not in an array because Ruby just doesn't support that. But what you can do is return a single array that is totally flat. So I just need to systematically work through all of these and make sure that what they return is a flat array, not a nested array that's got a structure. And then unfortunately, the only way I'm going to know if this has worked correctly is also go and make the matching change over in the evaluator to make it consume that flat array, and then hope that those two things meet in the middle and nothing breaks, which is not entirely satisfactory. And again, as Chris would quite correctly say, if I had unit tests for these things, then I would at least be able to update the unit tests for unfold and see them pass. And then if I had some test isolation so that evaluate wasn't actually calling the real implementation of unfold, it was just, it had its own unit tests that were feeding it what it was expecting to see, then I could keep all the unit tests passing even if the integration or acceptance test that runs those two things together was failing. But I don't have any of that. I've only got the acceptance tests, so I can only apologize. Anyway, hopefully it's all just arrays and stuff. Hopefully this isn't going to be too difficult an operation to perform. Right. Okay, well, I've got two problems here. Firstly, rest.map is going to return an array of arrays, because each call to unfold is itself going to make an array. So if I do like, 1, 2, 3 map unfold, I know this is a bit artificial, but I'm getting an array of arrays back there. So I need to use flat map here to flatten them down into a single array. But then I'm also putting this inside another array. So now I'm here, I'm putting, D, E, F on the end. But now the result of the flat map is itself in a nested array. And so I need to splat this out so that not only is the array itself flattened, but it also gets flattened against. Oh, and then I can, here, the analog is more that I've got these in an array as well. So I need to, this is an array that I myself am constructing, so I can just stop doing that. And then I can put a splat in front of this one. And then we get what we want. So, that's quite a lot of array shenanigans, isn't it? And, I could construct this array in a different way. I could plus two arrays together or whatever, but I quite like having sort of having this like syntactically one array. I think in terms of clarity, this makes it, to me, a bit clearer that I'm returning a single array. And then I need to do some shenanigans inside it to make sure that it doesn't get all nesty. But anyway, the short version is this is how I like it. So I'm going to do it like this. It's my project. So, tough. So here the result of unfold is going to be an array. So I have to splat that, get rid of these square brackets. This is going to be an array that is syntactically an array. That needs to be a flat map. That needs a splat. That's syntactically an array. I think that just needs a splat. That needs a splat, and this needs to flat. splat the unfold. See, this is what I'm worried about, is this if. Yeah, I think this is going to break. So I might need to back out of this change and make if compatible with this change. But I've been extremely recently bitten by my hubris, so that might not be true. But I'll be absolutely amazed if this flattening of ifs doesn't cause a problem. So this needs to be flat map. I can't splat this because it's not inside an array, but that's okay because this is the array that we're returning. Okay, let me read through this again. So that just returns the original expression. Flat map, splat, no new array. Flat map, splat, no new array. Splat, no new array. Splat, no new array. There's an array there, but we flat map and then we splat it. Splat unfold. Splat flat map. Oh, I missed one. What a muppet. Splat flat map. Splat unfold. Splat unfold. Splat unfold. Flat map. Don't need a splat because I'm not inside an array. Literal. Okay. So, I mean, this is the evaluator is not going to know what to do with this. So, yeah, it's instantly gone wrong. I'm sure if I run this test.sh, it's going to be just as bad. Yeah, I just can't. It just doesn't know what to do. So I need to make the, sorry I keep typing FG, I keep thinking I've suspended Vim, but of course I haven't, I've just got it in a different tab. Is this window a bit low down? I'm a bit worried, I'm just looking at my, maybe that's fine, I can't actually type in the bottom of it anyway. Maybe that puts it more in the safe content safe area on your Sony Trinitron upon which you are watching this premium content. Right, what was I saying? What I was saying was I need to even tell whether this is working in the absence of any kind of Zeterian unit tests. I'm going to have to just make evaluate work in this. Oh, look, I took this out entirely, so there's no chance of it working, was there? No, that's just the unit test passing. Float expras. No chance. No chance. So like I said, the input to evaluate is now completely incompatible with what it's trying to do. It doesn't know what to do with this. I mean, this does look like a nice, juicy, unfolded, flattened, linear sequence of instructions, though, which is great. But yeah, I have to actually deal with them properly. So I am going to take this out. So whereas, what do I want to do? I'm debating again about whether to keep rest here or whether I'm just going to reassign expression. I'm going to keep rest and just try and keep it as explicit as possible, I think. So this is going to be something like, but then how does expression get? Oh, okay, I know. Look, if I do this, if I do while expression in instruction rest, so this is going to match as long as this array is not empty, right? So as long as there is an instruction that I can pull off the front of expression, then this loop is going to execute. And then in here, I just need to, execute the instruction consuming sum of rest in the process, And then at the end, I just need to say expression equals rest. And I think I would rather do that than have expression be, because this condition here leaves expression in like a weird situation where like we've pulled the instruction off the front, but there could be one or more immediate arguments to that instruction inside rest here. And I think calling that expression is a bit misleading. Whereas at this point, we will have hoovered up any of those immediate arguments as part of evaluating that instruction. And then at this point, it becomes kind of syntactically valid again, an expression that could be reevaluated. So I think that's okay. Rest is sort of a low level detail here, and expression is something that we would expect to be able to evaluate, and it's really not that until we've done the execution here and we've consumed a meaningful, chunk of the flat expression that was passed in. So I was just thinking about the return value of evaluate. What am I going to do about that? I guess it just doesn't return anything now. Previously I'd had it returning rest. In fact, I remember I used to have it returning nil, but that was just a bit of belt and braces to make sure I wasn't using the return value anywhere. I'm pretty sure I'm not. So yeah, it doesn't need to return anything. So actually, I'm just trying to put the bread around the sandwich before I deal with the tofu in the middle. That's the end of the loop. And then this is the filling, I think. So whereas previously we would, and I mean, I could do this recursively, as long as you don't mind the Ruby call stack getting deeper and deeper with each. I can't remember what the status quo is with tail call elimination. I can't remember what happens. I don't know if the tail call optimization is turned on by default or not. Anyway, it doesn't matter. I did it recursively here because because it was easy. But now I think I'll just sit inside a loop. I'll keep updating the value of rest. And then this will keep trying to consume more instructions from it. Consume structured instruction is already doing the right thing. Oh no, sorry. Evaluate numeric instruction is the thing that's doing the right thing. We only expect this to evaluate one. Did I commit those raises? No. Okay, yeah, that was just my sense check of what I'd written. What was my previous commit? Yeah, okay. I added those raises after I made that commit, I think. Yeah, so this is already doing the right thing. It just returns rest, and then that's being used. So there's no need for this. This is designed to only evaluate one instruction. So we only need this loop at the very outside that is fed a big long list of instructions. Okay, well, let's try running it and see what happens. My prediction is that at least some of these previously passing tests are still going to be passing because they're not going to have those nested ifs. And I mean, it's possible they'll all pass because we don't have nested ifs anywhere. But that just seems a little bit implausible to me. Anyway, what I'm expecting is to see some passing, some failing, but it shouldn't immediately fail. I would expect all of those early ones to work because we've changed the format that instructions are written in, but we've also changed the format that evaluate expects them to be written in. So unless I've made a boo-boo, it should actually work. Oh, I've made a boo-boo. Crap. What have I done wrong? I mean, it definitely sounded like I knew what I was talking about, didn't it? But I think we have to face the very real possibility that I don't. Okay, let's do some puts debugging and try and figure out what's going wrong here. I mean, that seems to have fallen at the very first hurdle, which is surprising to me. I32 const. I just remembered what it was. It's the thing that I said I had to remember. And I did not remember it immediately, but I remembered it eventually. Which was this thing that I changed. I changed this from a flat map to a map so that we could keep it compatible with that, with what we were doing in evaluate. That is why this is a double open bracket, is because I'm unfolding the contents of that thing, and then it's inside a map, which puts it inside another array. So this is a one element array that has been both unfolded and then mapped over. So this was the one place outside of the unfold method. Well, this is the only other callee of unfold, I would imagine. I mean, yeah, this evaluates it directly. Yeah, there's all these recursive calls inside unfold. There's a couple. Yeah, there's this one because we need to evaluate the expected value inside assert return. But otherwise, this is really the entry point for evaluating the body of a function, and indeed the arguments to the function. I mean, really, I should have a... Really, I should have a function to do this. Like, evaluate should unfold whatever you pass into it and then pass it on to, like, evaluate unfolded or something. But there are so few callers of evaluate that I just whacked in unfold in what I think are the right places. Anyway, I'm not trying to keep you in suspense. Let's see if that fixed it. Yes. Okay. Let me take out the puts debugging. Okay, let's see how far it gets. So now let's just reset. I'm going to try and get back into that smug frame of mind I was in before, where I said that they're mostly going to pass, but I'm expecting it to fail when it finds an if inside another if. So let's see what happens. Looking good so far. Note that if wast is one of the things that I thought we might try. So if anyone's definitely going to test nested ifs, it's got to be if.wast. I mean, I'm surprised that it hasn't... Okay. So look, we do have a problem here that is sooner than tau. So the problem is in check. Why is that a problem? Oh, well, I don't think check is the problem. I think init is the problem. No, actually, I'm not sure what's gone wrong with this. Why is this not working? When I said I thought it was in it, I thought it was because that was this function, but this isn't. This is run. Oh, hold on. There's more than one function called check. I just noticed that this was not the argument up here. But it's this one, I think. Okay. So it does come after run. So init, 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 run. And then this is failing. So I think I was probably right that it is this that's failing, but this doesn't have an if inside it. Okay. Is this because... Okay, so my guess is that this is an unfolding problem because previously let's just look at what we've got. I think that this loop is not getting unfolded properly because there's a label here and then there's multiple instructions inside the loop. Loop. Oh no, we support that okay. And this block with a label. It makes me suspicious, this business here. Hold on a second. Why aren't I unfolding? Oh, I am. Okay, well, I must admit, I'm not sure what's going wrong here. There's clearly something going wrong either in the unfolding or in the evaluation of the unfolded. Like, I thought this was going to be... I thought it was going to be if related, but I can't see any reason to blame this on if, even though I'd really like to. It looks like it's just block and loop aren't working right. So I wonder how come this was working before. Like, clearly this was giving the right answer before. No one's trying to branch to that exit label, so it's not like a branching problem. Okay, well, Let's try running that test in isolation again. Spec test core float exprs.wast check.wast check.wast. So I think this is just the part that's not working. Yes, that is the correct incorrect problem. So expect all of those inits are probably quite important, but I also think check only does loads. So while init is storing stuff in the memory, I think I can safely take these out. Because I sort of want to make this I want to execute as little as possible to have like a minimal reproduction of the problem. Okay. So let's have a look at what unfolding is doing and also what execution is doing. Yeah, that's okay. I wish I'd kept that code in now. Unfolded. Puts. I'll do this in some kind of color. Green. No, I said green. I thought yellow. So what is this? Pretty print expression. And then that gets rewritten or unfolded to unfolded. I want to pretty print that as well. So this should at least let me sense check whether the unfolding is doing the right thing. It would actually be more helpful if I did something like this. If this was sort of indented. And then this was actually a new line. I think that would make it easier to see. Yeah, okay. None of that looks immediately wrong. Let's have another new line on the end there. Like, I can't see anything there that looks totally wonky. Let's see what evaluation is doing. Puts blue. That's not very visible. I don't know what the colors are now. Magenta, that'll have to do. Okay, so what do we expect to happen here? These 4 invocations of init are supposed to put 15.1, 15.2, 15.3, and 15.4 into memory location offsets 0, 4, 8, and 12. So this should be unfolded to local get I, local get x, f32.store. Local get I, local get x, f32.store. Okay, so that's been correctly unfolded. We're doing it. We're doing it. This all looks good. And then const 4, 15.2, doing it, doing it, doing it. Const 8, 15.3, doing it, doing it, doing it. That all looks good. And then run is supposed to it's not something to do with local variables, is it? I think what I'm going to do is get it to, instead of printing out the whole expression, which isn't super helpful, I'm going to have a look at what's happening in these cases. I mean, is this right? Instructions.each. Maybe that's not right. Maybe this should just be evaluate instructions. Yeah. I'm not really sure. I'm not sure if this is the problem, but this code doesn't make sense on its face, because the idea is that evaluate is supposed to take a flat list of instructions to execute, which is what the body of this block or loop or whatever is. It doesn't make sense to iterate over them and pass each one into evaluate. I don't understand why that's not blowing up in a more spectacular way. Similarly here, where we pass in a single instruction as the body, why is evaluate not complaining about this? Something weird going on here, but clearly there was more, I feel like there was more work for me to do in fixing up this. I sort of didn't really realize that there was more work here. If, again, I feel pretty skeptical about. Let's just see if that makes any difference. Oh, that's worse. Where did I put the where did I put the print in? So that's the unfolding. Exit, no matching pattern error. Okay, well, now it's even worse. Block, exit, loop, cont. And then somehow it's including the exit? Oh, it's because this isn't matching. Right, okay. Yeah, the chickens have come home to roost on this one. So the fact that we had this set up weirdly so that it only matched a label before a body that was a single instruction, now the body is not a single instruction, it's a flat array of instructions, and so this doesn't match anymore, and so we fall through to here and we try to evaluate the label, which doesn't make sense. So this needs to be a splat. Yes, okay. Wow, all right, well that was more subtle than I would like. So does this even get... I honestly don't understand how this works. How can this possibly work? Oh, I need to take those putses out. I mean, I'm loath to change this unless it breaks, but I just don't believe that that could ever work. Yeah, I don't know what's going on there. I mean, this whole area of code was bothering me before because I knew it wasn't right, and now it's very not right, but I'm not quite sure how much of it to change and how to justify that change, because unless there's a failing test that's causing it to not be right, then my level of confidence that I'm actually improving it is quite low. What the hell? Why is check failing? Oh, crap. I didn't mean to do that. Hold on, I'm really confused. Okay, so is this caused by me... Is this caused by me saying, oh, I don't understand why this wasn't causing a problem? Is it actually caused by this? Yes. Okay. All right. Well, I'm sorry I wasted my own time there by not cleaning this up earlier, but okay, it really feels like I've made a lot of changes here. So what in fact have I done? Okay, I'm going to stash this. Firstly, I think this assigning this to rest is something that I should have done in the previous commit. Consume the correct number of arguments for structured instructions in evaluate. Or maybe even earlier than that. Consume the correct number of arguments for plain instructions in evaluate. Yes, it should have gone in there. So I'm going to... Let's just fix that up real quick. So this should be rest equals. I think I can just... I think I can just justify that in the context of this. I think it just belongs in that commit. You know, because a numeric operation is a kind of plain... a numeric instruction is a kind of plain instruction, and so it just belongs there. So that's fine, I think. And then... and I suppose that fix I did just sort of belongs in this change, because this is where everything becomes flattened, and that necessitates changing the way that, you know, we can't just iterate over these anymore. So I think that's probably okay. Ditto the splat here. It's all just part of what is required by making unfold flatten its arguments. It just blows my mind that if isn't broken. But it's not. Oh, looky here. No fold LT if. I spoke too soon. F32, no fold LT if. So this is a little odd in that... Oh no, this is exactly what I was worried about, I think. That... Well... I think it's possible that we could make this pass, actually, by a... Well, it's not going to allow this. That is not a valid find pattern, I don't think. No. But this is the problem, is that now when this gets unfolded and flattened, we end up with multiple... It's not just a single instruction here. It's going to be local get X, local get Y. Oh, sorry, this is the condition. So it's saying no matching pattern error. If result F32. Why is this? Given 8, expected 6. So if there's a type there, yeah, local.get. Yeah, it's just because this has been flattened. Look, local get X, else local get Y, end. But this array is only 6 items long because we don't have any ability for consequent and alternative to be arbitrary length because of, and that's, so even though there's no nested ifs here, there's still a problem with just the basic pattern matching of this. And it is possible to hack this to work with a find pattern, and I could turn off the experimental feature warnings. But that fundamentally doesn't solve the problem that I know that I'm going to have if I don't parse, if I don't employ a recursive parser here, then I know I'm going to have a problem anyway as soon as I encounter nested ifs, and I don't know if there are any in here. But I think this is enough to provoke me to do that thing that I thought I was going to need to do, which is parse the contents of an if to find the else that matches the end and the if that firstly could be at any arbitrary position in the array, and a find pattern would be able to find it in the case where there aren't any nested ifs. But I might as well just do it properly. I think I don't really want to bodge this one. Because I can't believe that I'm not going to... I mean, let's have a look at... I mean, what is... there's nothing stopping me from just running that if.wast, like... Oh, it's got a different problem. It doesn't... Memory 1. Okay, well, I won't get distracted by that then. But, well, here's me not getting distracted by it. I'm going to look at it. Yeah, look, I mean, here's explicitly a test for nested ifs. I'm definitely going to need to be able to associate this else with the correct if. Or, that else needs to be associated with that if, not that one. So I think I'm going to go ahead and do that. And that means that essentially I'm backing out of that change this change that is almost working. I don't think I'm ready to make it work because of the if problem. And in fact, I don't see why I can't... I don't see why I can't separately fix up the splatted body problem here. And I'm also not sure whether I need to... So yeah, I'm sorry about this. I realize we're kind of backsliding here. But I want to find out how much of that stuff I can change before I do that commit. Yeah, so that seems okay. So that's good. So I'd like to make these little fix-ups that I needed to make here to slightly generalize what this is capable of doing, such that it continues to work properly. I think I'm gonna make those changes now. Then I'm gonna fix up the if, and then when I do make that big throw both switches at once, it's gonna be the smallest change that I can possibly make at that point. Yeah, okay, that's good. So tau is still working. So it's evaluate instructions, and then the other thing was here, making this be a body. So really all of this is taking advantage of the fact that evaluate is now compatible with an array, which was already the case. It doesn't depend on that change to evaluation to support flattened instruction lists. It's just this shim already allows that. Actually, I'm not very unhappy. I'm not very happy with these long lines either. So I'll go and fix those up while I'm here, because otherwise I'll never fix them. So let's say I think I can do all of these actually. Do something like take advantage of evaluating an array of instructions. Well, let's just say support evaluating arrays of instructions when evaluating block and loop. This is already a slightly neater way of doing what we're already doing, enabled by the fact that evaluate now supports multiple instructions, albeit not flattened yet. And it's also required when we move to executing flattened instructions. So changing it now means that there's less to change later. So it's going to be a similar spirit of change for if, I suppose. It's like I don't have a great justification for needing to do it, but I'm gonna. Let me deal with these long lines. When I wrote those lines, that function was called foo, and it wasn't too long, but now it's not called foo. I mean, this one in if is almost too long, but I'm about to work on that. So, so what do I want to fix up? Is it this one? I believe that it is. Yes. All right. Love it when a rebase just works. So such an unusual feeling. I thought it was gonna be a merge conflict because I made that edit quite close to there, but it was just far enough away that everything was fine. Well, it wasn't far enough away, but Git just managed to figure it out. So that's great. Thanks, Git. Right. So what is it that I want to be able to do here? I'm going to go back into wishful thinking mode. I'm going to optimistically remove check.wast as a defiance, as an act of defiance, and that I can't believe that I'm going to need to run that again. I've definitely moved past that now. There's no way I'm going to need to recreate that file and run those tests yet more times. just thinking about how I want to do this. So I've already got this. So there's nothing wrong with this. I mean, apart from the fact that it only works if there's definitely a type, and it doesn't work if there's a label. But the only problem with it is that I can't, this bit doesn't work right. Like, I can definitely find the body of this if, I called it instructions there, instructions. All right, I'll call this instructions. But the problem is that what I need to do is I need to foo those instructions into consequent and alternative. So this is a very similar job to what consume structured instruction is doing. It doesn't need to return rest because I already know that I need the whole thing. So if it did return rest, it would only ever return the empty array, so there's no point. But what this needs to do is like split these instructions on else, but not just by finding else, but by recursively consuming structured instructions as it finds them. And then if it finds an else that is not inside a structured instruction, then that is the place where it goes. Maybe I'll just call this split on else, because that's what I said. Is that right? I think it is. And I don't actually want the else. You know, that's what I was thinking about, is that like here, consume structured instruction gives you the if and the end. I don't see any point in this, because this sequence of instructions is not actually valid. Like, you can't execute it because you've lost the structuredness of it. There's an else that's glued in the middle of it. So really, you know, the reason to retain the beginning and the end here is to keep it as a nice, structured, executable instruction, whereas here, it already isn't. It's two executable sequences of instructions joined together by else. So I think I'm just gonna leave it at that. So split on else instructions. I mean, I called it expression here. Maybe I'll call it expression, given that expression is a sequence of instructions. But I mean, I feel like I just explained why it's not in this case, but whatever. So I want to do something similar to what I did here. Like, basically what I want to do is just accumulate. Instead of accumulating instructions, I want to accumulate the consequent. Like, the return value of this is going to be the consequent and the alternative. Well, that's going to come later, right? For now. I don't have anything initially to put on there. And it's not really a rest situation, because here I pulled the instruction off the front and then I had the rest. Whereas here, I think I really am just consuming this expression. And instead of saying until expression in end, I'm saying until expression in else. So case expression. And I guess this is the same thing. Like, if what I have found here if what I'm about to read is a block or a loop or an if, then I need to consume it. This here is consequent. Sort of running out of variable names here. How about, okay, this is less of an expression than what I've than what consume structured instruction returns. So I'm going to call this instructions. That's what the caller calls it. So this is just instructions in blah, case instructions in this, consume structured instruction from these instructions. You get back an expression and the rest. It's not the rest, it's instructions again. So that overwrites instructions because we've extracted the expression from it, and then we concatenate that onto the consequent. Otherwise, if we've just pulled one instruction off the front of instructions, then the consequent will get that instruction added to it. And then we don't need to do this thing at the end where we add another thing. So I think that... this is a bit of a mess, but I think that's the thing that's going to fill up the... Maybe I can just do this. That's going to fill up the consequent. And then the alternative is almost exactly the same. Except now I'm not looking for else followed by instructions. I'm looking for nothing. So when instructions runs out, I mean, this could be that, but I think for symmetry with what I'm doing up here, consequent alternative, I think that's right. Let's try it out on FlowExpras. Okay, well, it hasn't broken anything. I mean, this was working. This was already working. So I can't claim that as some kind of... It hasn't fixed anything yet. But it also hasn't broken anything yet. So it's impossible to say whether it's good or not. I think this is okay. I think I'm going to commit this. Is that line too long? I suppose, yeah, it's too long for my editor, so I suppose it is too long. Okay. So how am I going to explain what it is that I'm doing here? Again, I think I'm just gonna... What did I say for this? Define split on else method. So I'm gonna... In fact, I'm gonna copy all of this. Let's work out what I actually want to say. Oh, yeah. As explained in blah, the existing the existing method consumes structured instruction doesn't deal with the else atom inside the body of an if instruction. To find the correct else in the presence of either nested ifs or ifs with multiple instructions in their consequent or alternative, we need to recursively consume the entire body of the if and find the matching else. That's what this method does, and I'll hook it up to the evaluation of if instructions in the next commit. I mean, arguably it's a little bit weird to be adding methods in that aren't being called anywhere, but the reason I'm doing that is because I just want to have a space to write a paragraph of text that isn't about, well, I mean, I suppose my next commit is going to be pretty vacuous, isn't it? But I don't know, I just felt like I wanted to, it was a large enough thing that I just wanted to separate this change out. Yeah, consume, correctly split if body into consequent and alternative in evaluate. As the previous commit explained, we have to do this recursively. A find pattern, in addition to being experimental, in addition to generating a warning, does not know how to find the correct else that matches the if, e.g. i.e. in the presence of nested ifs. Okay. All right, so I think I've dealt with all of the problems, or at least in this very narrow domain of problem. Let's find out what happens if I... Yes, even Git can't merge this without my intervention. Oh, this is a real mess, isn't it? Because it's all indented. Why don't we restore theirs and then look at the diff and see where we have backslid. Well, that's fine. Those are legitimate changes I made. That's just wrapping. Line 318. Overshot a bit there. So I just need to, the quickest thing is just to do it myself. Instructions, and then split. Oh yeah, the definition of split on else is gone, which is obviously a problem. Okay. So what else? Or is that it? That's all okay. In fact, why don't I? Those are all changes that I want. That's good. Wow, I'm going to have to fix these up myself. Because of the indentation situation. Okay, so that's all good. Oh yeah, like no changes. So the only change inside evaluate is the while loop and expression equals rest, which is correct. And then split on else is being removed, which I can just not do. So I think that's it. Float expras. Has it fixed the problem that we were seeing? 1, no matching pattern error. Well, that is at least a different problem. I think I'm going to commit this because I just did a lot of work to fix a single problem. It is obviously still failing. But I feel like I don't know. I've made some progress. I might end up having to amend this commit if it turns out that it's got some kind of mistake in it, but I just want to lock it in. Have I still got that? Yeah. Flatten expressions when unfolding. This means evaluate has to repeatedly pull instructions off the array until there are none left. And unfortunately, I'm going to have to do a bit more debugging to figure out what the next problem is. I mean, I can't immediately tell whether this is being caused by what I've done or if it's being revealed by what I've done. Let's just check that all of the normal tests pass as they should. Okay, it's looking hopeful. So yeah, I mean, obviously I don't know. Yeah, I don't know whether I've broken something new or if I've fixed what was broken before and now there's something new. But this failure is at least inside tau, which is pretty much the extent of my, understanding of what the problem is that tau doesn't execute. So let's have a look at tau. Okay, so it's that very first one that fails. In evaluate 1, no matching pattern error. Okay, well, unfortunately, I'm once again going to have to add in that stuff that I took out because my optimism was misplaced. Let's see. Let's try just looking at what is getting evaluated here. Okay, so there's something straightforwardly wrong there. So evaluation gets, so that's the argument that tau's getting called with, I think. Yeah, const 10. And then it starts in, oh, this is the wrong file. So it starts in f64 const 0. That's all okay. Local set 1, and then into the block. Block, local get 0. We go in okay, local get 0. I32 const 1. I32 less than signed. Branch if 0. I guess it didn't take that branch because we're falling through to f64 const 0 there. Local set 2. More spam in the chat. Local set 2. Const 0. And then loop, local get 1. And now we've got loop has disappeared, local get has disappeared, and we've just got 1. So something's gone wrong with either the unfolding, well, it must be the unfolding, or the evaluation. I guess that's the problem, is that we've got the same code in both places, so if it's wrong, it's double wrong. Okay, so well, that wasn't too hard to narrow down. I think it's in loop, yeah. So this is the problem. It's just assuming that there's a label, and in this case, there isn't. So what I'm going to do is, I mean, that label is not even being used, but it does have to be. Well, I mean, clearly this loop in this implementation of loop is not correct because the label is not being used at all. Well, it gets passed in here, label to sim. So actually, sorry, I tell a lie. It is being used because we catch it. But in this case, it's just brf0. So I think we're going to have to do something here that, like, you know, can cope with the fact that there's no label. So this needs to come out of here. And there's going to be something that's like instructions in label instructions. Well, in fact, this can be a conditional, right? If that is the case, then great. Else, I guess. Oh, hold on. So actually, what we need to do. Okay. So we do actually need to create a label here. If this matches, well, look, obviously we need this. This whole thing is a flipping mess. So if we have something that is syntactically looks like a label, it starts with a $sign, then we consume it and we symbolize it. Otherwise, you just get 0. and then this just becomes catch label. Because down here, we're going to throw 0, I believe. What does BRF do? Yeah, look. If it's not a label, if it's a number, then this will actually be a Ruby integer. So we have to have... I mean, obviously, I haven't thought at all about what happens if you need to break out more than one level, because we haven't got any more than one sort of enclosing scope, because that hasn't happened yet. So right now, I think the only number we get in these is 0, and so as long as I provide 0 here and we catch it, then the semantics should be correct. How the hell was this working before? I guess it's because the instructions weren't flattened. It was okay for it to just... It was just evaluating... Yeah, I'm not sure how this was working before. I mean, I assume that what was happening before was that evaluation didn't even make it this far. I think that's probably the truth, isn't it? That we didn't get down to this loop previously because it blew up at some, we were trying to evaluate this or some other nonsense. So yeah, I think this probably is an improvement. Yes, it's failing because more stuff is working, which is not a pass, but it's less of a failure. Okay. Well, I don't know why I'm so convinced that I fixed it that I haven't even run it. Tau. Tau has executed successfully. So there's only one thing for it. I'm going to run float expras and see if this passes. Yes. It's taken me so long to get this single test passing all the way to the end, but it has finally fallen. Ah. What an epic reorganization of my code base was necessary to be able to evaluate this. But I'm glad I did it, because now we're much closer to being able to execute real WebAssembly code. Okay, so this is going to be... catch labels correctly. Well, let's say find and catch labels correctly in loops. And I believe that is actually not the full commit, because I am also going to have to move float expressions from pending to script. I should call that passing, really, shouldn't I? I mean, I know this is going to pass. I don't know why I don't think there's anything non-deterministic about it. It's just a different experience to have it run as part of the main passing tests rather than something that's expected to fail. Okay, amazing. I feel happy about that. Okay, great. So a couple of things. So firstly, there's definitely some cleanup that I can do. I think a bunch of those cases in Unfold could probably be combined. I think I am going to do a little bit of cleaning up, actually. It's only midnight. And I think even though my brain is running low on brain juice, I think I can do a little bit of cleaning up. So what were my... Well, firstly, I've got my to-do list, haven't I? Tick, tick. Yeah. Oh, I'm not going to get distracted by that. This is all problems for another day, outside of the stuff that I've just been dealing with. But so the things that are bothering me about this code are, I think, the structured instructions here, block and loop and if, are extremely similar. And I think I should probably reduce the duplication of those. And yeah, the duplication in Unfold, basically. Like those, I think those are my two primary beeves. Am I still... I think I'm going to stop doing these defensive nils because I think their usefulness is no longer... it's more confusing than helpful, I think, at this point. It was definitely helpful for me to feel confident that I wasn't accidentally, that wasn't inadvertently using those return values when I wasn't intending to, but I no longer believe that I might be. So I don't really need to worry about that anymore. So that's an easy fix. Remove defensive nil returns. These were useful while I was weaning myself off of method return values, but that's all over now, so I don't need this safety net anymore. So in Unfold, I guess what I need to work out is how many of these cases are actually different, because I think there should probably be do we still need this? Does that still do something useful? I think that might have been, a shim, essentially. I can't get my head around whether that's doing something useful or not. It doesn't seem to be required. Yeah, because ultimately this has to support all possible instructions, doesn't it? We need to be able to... I'm not sure. I'm not sure about that. I'm gonna think about that. But all of these, essentially what they should be differentiated by is sort of the arity of these instructions, not with respect to the operand stack, but with respect to their immediate arguments. So so this one's got 2. Sorry, this isn't very gripping content, but I'm just trying to think about, like, here's the thing I'm thinking about. Local.set and local.t have got one immediate argument. BRIF has got one immediate argument. These const and local.get have got one immediate argument. So I think it's probably possible to write all of these in the same way. Like here, this is an instruction. Name is its singular argument. Oops. And then this value is just the rest and I think the same thing applies here. That this has got a label, that is its solitary argument. There's a condition here, but that is just the rest. I think. I don't know why I'm using float expras as my stress test here, but just because it was such a nightmare to get it working, it feels like if that's happy, then probably everything's happy. And I think, although it's a little bit obscured, I think the same thing is true here. I think this is an argument. This is an instruction. The expression here is the instruction and the argument. And then there's an empty array at the end here that we're flat mapping over. Which I know sounds a little strange, but I think by doing that, you can see that all 3 of these are actually the same. Are there any others that are the same? Those have all got one argument. Well, I mean, I'm just going to... And then BRF. Because, I mean, I've convinced myself that those are all the same. These ones are special because they've got this static offset argument. So this is just initial instruction and then the rest. I think this is just the same, right? Value 1, 2, and 3 constitute the rest. Like, if we're not discriminating based on syntax, so like here we need to check that this argument here actually is a static offset, because that's optional, so it might not be there. And if it's not there, then I think it falls through to this next one. But if all we're doing is just slurping up, you know, in this case, if this is a folded select instruction, then it must have value 1, value 2, and whatever the other one is called, condition. They must be there, so we can just map over them. That's not true for the block, of course. Actually, I wonder if this matters, because if you unfold something like a label, it's just going to pass through unchanged, because there's this sort of fall through case that is like leave things unchanged. I'm just going to keep running the test to make sure that I haven't broken anything here, but when I run the tests, it does actually make the stream go a bit choppy. So maybe I should lay off on the constant running of tests. But this suggests to me not only, I mean, this is basically the default, right? That like, you've got an instruction at the beginning. It doesn't have any immediate arguments. I mean, it's sort of this canonical, you've got a plain instruction, and it doesn't have any immediate arguments, and then it's followed by a bunch of folded instructions that you have to unfold. So not only are these the same, but I think they could probably be like a fall through case. And they don't even need to be so specific. Like, this is just like, well, we've got all the special cases that involve labels and offsets and all that kind of stuff. And then we've just got a default here that is like, we've got some plain instruction and then we've got the rest. And this doesn't have any immediate arguments. And so we can just unfold everything else and stick it in front of it. And I think this actually covers I think this is achieving what this would have been achieving, right? The fact that this... I don't think we're using this anymore. I think that this is the thing that really causes everything else to get recursively unfolded. Sorry about the stream. I just want to know that I'm not breaking anything. So these are all the ones with one... I mean, the syntax of this is sort of different in every case, but it's not optional. So these always take an immediate argument, and the fact that we're not checking it is just because it doesn't matter what it is syntactically, because it has to have that immediate argument. For these ones, we have to check the offset because it's optional. So we only pull out the static offset if we know that it's there. Otherwise, it's going to fall through, I think, to this case and say, well, this instruction doesn't have any immediate arguments. Let's just think about these for a second. So what I was saying about labels was that I suspect that this is not adding anything. I think if we allow the label to be swept up into these instructions, and I suppose I would assert the same for loop as well, if we allow the label to be swept up into those instructions. Because look, it's just being prepended. You know, this is the best illustration of that. It doesn't get moved around, it stays at the beginning. So if this label got slurped into the beginning of instructions, we wouldn't need to put it in there. It would pass through the guts of unfold unmodified because it doesn't match any of these other... And it's a little bit of a cheat, but I think, yeah, not very principled. It's probably like a type error with respect to what unfold does. But in practice, I think we can just let it pass through its digestive system completely unmetabolized. So actually, that makes these two cases the same. Oops, not a Ruby loop. That's... Don't know. Accidentally reach up into the meta language. Anything can happen. So I think that's right. I can't see any other low-hanging fruit here, but I think that was all good stuff. The block and the loop handling is consolidated. All of this stuff that's got a single static argument is consolidated, and I can easily add more instructions in here as we need them that are like that have a static arity of 1. And for ones, and static arity of 0 is just the default. So if I'm adding any instructions that have a static arity of 0, then I won't need to add them to an ever lengthening condition, because it's just that's where they go by default. So I think that's good. I think that's a good simplifying change. Combine some unfold cases. The block loop label will pass through unfold safely. Local dot set local.t and br if are the same as the const instructions, they have a single static argument. And by making has 0 static arguments, the default, we can avoid listing out all the possibilities, e.g. what did we end up removing here? Select I32 add, you know. Okay, that's good, I think. Is there a way that I can... The only other thing that's... I really appreciate this because it feels like this has shaken out one of the things that was really bugging me. It hasn't shaken this out, but it's shaken out the... Just trying to think whether I can get rid of type here. I don't think I can. No, it wouldn't magically end up in the right place. It has to remain distinct from the condition because the condition moves to the other side of the if. Sorry, what was I saying? I like the fact that this has sorted out some of the problems around whether it's got a label, and I think that this will sort of sort out the type as well. I mean, maybe it's bad that I'm not explicitly acknowledging that, but I mean, it might just be that I haven't seen a block or a loop with the type on it yet. Maybe this doesn't work for those. But I like it that it's regularized the handling of blocks and loops, if not conditionals. And I wonder if it's possible to get some of that regularization benefit on the evaluate side, because here I know we've got block and loop here and if here that have very similar contents, and I wonder if it's feasible. Like, they all call consume structured instruction, for example. Let's just see what that would look like. If I could share some code here, and furthermore, if I can regularize the handling of the types and the labels, it feels like that's going to save me pain in the future, because inevitably we're going to see every possible combination of those things. And at the moment, I've been sort of catching them as and when they crop up. But if I can just share the code that deals with them and not have to constantly debug it each time, I think that would be a benefit. So the idea here would be to try and catch all of these. I can definitely consume structured expression, but I guess it's going into... Oh, it's not so bad. It goes into instruction. Well, I mean, maybe I can do this. Maybe I can pin it. Just to make it clear that, like, the first thing you get is block, loop, or if. Then you get your instructions, I suppose. And then you get your end. And then you get your rest. this isn't really doing anything. It's just got, I suppose, sort of documentation value. So that these all end up doing that, don't they? And they all just leave. They all just leave the body in instructions. Except in this case, it gets the type out. But surely that's something. Look, all of these can have a label. All of them can have a type. So what I should do is just, wherever that code is to deal with the label, let's just have that. So that's just going to consume the label off the front, if there is one. And and same for result. Or type, I guess. Do all of these handle labels in the same way? I suppose they probably do, because it's the same. It's syntactically the same. So whatever it is that you do, say like, oh, I'm going to turn it into a symbol, or it's going to be an integer, then yeah, I think that's probably right. My gut feeling is that that's right. So same for the instructions in result. Like, that's taking the type off the front. We're not actually doing anything with that as far as I know. Yeah, it's that, you know, it doesn't get assigned to anything. It doesn't get bound to any variable, and there's no variable pattern inside it, just underscore. So I think that's essentially ignoring it. I think this is probably wrong. I think this evaluate body locals without a catch around it is probably just a leftovers from something I did in the past that never branched. I think it should look like this. So I think let's have another case instruction in block. Basically do that. In loop, it's going to be essentially the same, but with a loop around it. And then in if, I mean, it's totally different, but just this bit. So we've kind of front-loaded the splitting, the sort of finding the extent of the full instruction and parsing out the label and throwing away the type. Yeah, and then all of the rest of this is the stuff that's really specific to the semantics of what is the difference between a block and a loop and an if. Well, these three things, that is the difference. Everything else is what's common between structured instructions, basically. Yeah, well, I find that convincing. So that makes me feel better, not just because it's slightly less code, but also because it's sort of more regular for these three instructions that share a lot of the same features. We've just, at least syntactically, then we've sort of consolidated those syntactic concerns here, and we're handling them all in one place. It's just a shame that in Unfold we've still got this type in here, and there's no provision for a label. I guess I'll leave it for now. It's gonna fail, obviously, if we try to unfold an if. Oh, is that true? I don't know that it is. Maybe I should fix that while I'm in here. While I'm thinking about this and caring about it. So here, let's just say combine block, loop, if, execution handling. These three structured instructions share similar syntax, i.e. Label and block type. So it makes sense to deal with them together. We weren't previously supporting all combinations of label and block type across all three instructions. So, but by handling them all at once, we get consistent behavior across. There we go. Okay, well, that's a bit hand wavy, but whatever. It's 12:30. What was I going to do? Yeah, I was going to try and find a way to make this work. See, it's really the limitations of pattern matching, I suppose. But I don't see any reason why I can't do this piecemeal. So if I have, I think this is what I want really, is for this is what I was saying before, like, oh, it'll fail obviously if I get one without a type, and I'm not sure it will, because it'll just fall through to this and it will like scramble the expression in an incorrect way. So that's not what I want. I think what I want is for this to match, and then I'm going to do all the business inside here. And I could have done that for block and for loop as well, and maybe I should. Maybe I'm setting myself up for future pain. Let me see what this would look like. What did I say the order was here? Label and then instructions. Sorry, label and then result. Label and then type is the point, is what I'm trying to say. So this is just so that I can refer to it. So I think here we can just do this basically. So rest in, pull out the label, and at the end, whatever I do here, at the end, I'm going to say rest in piece, rest in empty array, because if there's anything left after I've chopped out all the bits here, then there's a real problem. Although I suppose actually the last thing here might be end. Yes. Okay. Yeah. Okay. So that's not gonna work out this way. Okay. And then here rest in result underscore becomes type. So because these are ins, they can succeed or fail, and that's fine. And then these local variables just won't get assigned in that case. I think they'll just be nil. So try to get a label. Try to get a type. And then I think it's just this actually. Not type. But everything else, condition, oops. Condition, then consequent, else alternative. And then that's just the end. Yeah, so that sort of, if there's a syntax error here, then we'll get a pattern match failure because it won't find those pieces in the folded if expression. And then the result here is unfold the condition, instruction type. Yeah, what should I do if there isn't a type? What should I do? And label, and that's what this says. Folded instructions, that's this. That's the condition. If label block type, instruction label type, instructions else blah. I'm actually skeptical about something here as well, but oh no, forget it. It's not important. It was more rubbish about what are we allowed to call unfold on, because these are folded instructions, whereas these are just a mixture of regular instructions and folded ones, but whatever, doesn't matter. It should probably be mapping over those, to be honest. But whatevs. Yeah, actually, let's do it properly. Each of these should be splatted. I don't understand why they're not. Let me see if I can get it working first, and then I'll change that. But it does bother me. So label and type here. Can I do a trick? Can I say, like, if I want to do like A, B, well, let's say label equals label, type equals nil. And then if I say A, B, I've got an array that will have label and type in it. C, D. So if I just stick label and type in here, oh, that's not even right, is it? Okay. All right, so now that's clearly not right. If I splat it, then I get a nil. But if this was compacted first, then I only get the label. If type was set, then I get both. If label is unset, I only get the type. And if type is unset, then I get neither. So I think splat and then splat with compact, I think, is my friend there. So I think that's right. Again, if this passes, I'm going to believe that it works. Let me just try that splatting I was talking about, because this says, you know, in the same way that it says block label block type instra splat, you know, I've got a splat here. I should really have, and I think I can. Because it's nested, I think I can splat these. And then I would expect this is going to fail. But then if I map if this doesn't work, I'm just not going to not bother, but if it does work, that would be lovely, because that better matches my understanding of what should be going on here. I suppose it should be flat map, actually. And it should be splatted. So let's see what's happening. Yeah, that's also not good. So if I flat map all of these, and then I splat all of these, then does that work? Yes. Perfect. All right, well, let me just format this. Maybe given that this, I think it would be easier to read if I just literally put if here. I think that's rather nice. I quite like that. Is there any meaningful sense in which I can give block and loop the same treatment? What would that look like? If this was block, loop, instruction. I don't need to splat out the condition and the consequent and all that stuff. I do need this. There are two commas. So I think I can do that. Does that work? No. Oh, I need to do what do I want to do? Basically, I just want to do this, which is a bit silly, but I think it's worth doing that for consistency with the if implementation there. Yeah, that's actually rather nice. And then can I consolidate the three? If I say, we'll take all three of those, please. We always do the label and the type. And then it's just this that varies. So here we do case instruction in block or loop. We do this business. And if it's in if, then we do this business. So it's kind of populating either just the instructions there or the slightly more complicated structure inside a conditional. But now that's completely, in the same way as we did on the evaluation side, it's completely consolidated the... There's a bit of duplication there, isn't there? Maybe I could extract this. There are two commas. I think now I'm going to put instruction back in there, even though it makes it a little bit harder to read. I think I'd rather have the consistency. Okay, let's try that. I'm actually really happy with this. I wasn't expecting to be able to bang it into this kind of shape, but that makes me much less worried about it being wrong. Just going to let it run through just to triple check that that hasn't broken anything in any of the other tests. I don't know that I have anything else that I feel like I immediately need to sort out. I would like to see if I would like to see if I've got anything for free. So before I wrap up, I'm going to try running all of these and see which, if any of them, already work, because I'll take that. Okay, so what did I say? Basically, combine, block, loop, if, unfolding. These all have very similar syntax, so we can share most of the work of unfolding them. Cool. Okay. I am really curious about this. I think I had... See, this was on the stash from a while ago, and that's what we're missing to run this if.wast, this memory one. Type. Okay, hold on. I'm sorry. I'm just gonna, because I feel like I've spent so much time tonight on getting if working. If there's a hope in hell that I can get this working, that if.wast, then that will feel like a bit of a payoff. So what is this? Type. Dollar check? What does that mean? Is it just some kind of identifier? In fact, where even is that? It doesn't make sense to me. Oh, it's not in... Right. Okay, that does make sense. It's at the top level in a module. It's not even part of expression evaluation. So somewhere in here, in interpret, so here we've got func memory. I could just put in a dummy type. And I mean, whatever that does, it's probably to do with type checking. Table. Don't know what that does. Global, I can sort of guess what that does, but... Local get 0, then... Invoke empty. If local get... Oh, look, this has got... It's got no... I mean, I think that's okay. I think I can support this. I think I can support having no consequence. But I don't currently support else being entirely missing. I'm just going to look at this really quickly. If it's not happening, then it's not happening. So there always has to be a condition. There has to always be a consequent. So that we support these empty like I think yeah, hold on, what am I'm trying to think straight here. So if that's splat rest, and then okay, my brain is stopping working. This would have to be like this. And then because this is optional, I better had check that either way we've consumed everything. So how do we deal with the fact that this might be empty? Is it just this? Because it would be nil in that case. We can't flat map over nil, but I can just default it to the empty array. What? Oh yes, well I didn't want a find pattern, did I? What am I thinking? I said I had a syntax error. Oh yeah, I do. It's the wrong kind of OR. Okay, is that... I think that has made pass some things that weren't passing before, even though I'm getting the warning. Singular. Nop. All right. I'm not going to spend I'm not going to keep going on this. I wanted to see if it was quick. I'm starting to suspect that it isn't. Let's stick it in here. Nop. Do nothing, I guess. Multi. What does that mean? I32. These can have a type as well. And they can have multiple return values. Okay, that feels like too much for me to take on right now. I'll stash this. I'll come back to it. So before I wrap up, let's look at... So I'll comment out all of this stuff. And let's, in pending, say we're going to try brif const data exports float misc func if labels load local get local set loop memory return select store. All right. Are these all failing? Ah, const.wast is passing. Great. So I'll add that to my passing tests. I will remove it from here. Okay, try again. Float misc. Okay, that's good. I don't know what that is testing, but I'll take it. I'll put that with the other float stuff. I think that seems appropriate. Okay, and all the rest of them are failing. Okay, well, I'm going to leave... I'm going to leave if there, because it feels like I've started making progress on that. But otherwise... so hopefully we're going to see const and float misc. I'm pretty sure, I don't know why I picked on this one. I think it's just because I spent so much time thinking about conditionals this evening, I decided to, you know, finish the job, basically. I think all of this stuff is easy enough to support. It's just I'm going to have to deal with, I didn't realize that you could have this sort of multi-type syntax thing. And I'm not quite sure how we deal with... Oh, I mean, I suppose multiple return values it just means that you've left several things on the stack. So the tricky thing is doing the type checking to check that you do definitely do that on every control flow path. But for the purposes of this, we assume that all of this code has already gone through the verifier and is all type correct. So I think it's just a question of, I guess I just need to correctly ignore this. Anyway, that all passed. So let's say add float misc.wast and const wast to parsing tests. I haven't even looked at these, but they are already parsing, which is great. And then let's say add if.wast to pending tests. This looks like it should probably mostly work, but it's going to take a bit more tweaking. And then of that stuff that I stashed, how much of this is actually usable? I wonder what would happen if, Because I'm getting that warning about, I was sort of trying to avoid find expressions. Maybe it's okay here though, like I really do mean it. So hold on, let's add some stuff here. Add support for memory with minimum size only. So let's say skip type table and global commands for now. I don't know what these do yet. Oh, the NOP is easy. The old classic commit message, implement the NOP instruction. What would this look like? It would look like an asterisk there so that we can consume multiple result types. And I guess here, so that we can support multiple result types. Still doesn't work. Let's just see what. I'm sorry. I'm just very curious about this. Because it feels like it might be really close to working. I32 result. Is this unfolding gone wrong? I32. Is it this? this I32, I32. So that's not actually part of the executable code. That's part of define function. Yeah, look. That needs to be an asterisk. Otherwise it gets added to the function body. So you gotta be really careful about this. Dummy. Oh, well, I don't support the call instruction. I'm sorry. Looks like call takes an immediate argument. Evaluate call, no matching pattern error. I must be able to call a function though. What is it? Name. Puts calling function name. Oh, well, dummy doesn't even do anything. So that's fine. Let's say to do. Actually call the function. Drop. Drop, drop. What does that do? The drop instruction throws away a single operand, so that means it pops something off the stack. In drop, stack.pop 1. Unhandled exception. Okay, it says this is getting a bit complicated, isn't it? Okay, all right, I'm calling it. But there is some stuff. There's some good stuff there. So it's something like support multiple value return types, I think. Result types. Support multi-value result types. Yeah, that's what it says, multi-value. When was this merged into the spec? Oh, 2020. Okay, well, not so bad. So let's say add dummy implementation of call instruction. say in if.wast, the function being called is dummy, and it doesn't do anything. So for now, I can get away with doing nothing when that happens. Implement the drop instruction. That find pattern warning is really annoying. Roll on Ruby 3.2. Let's say make else clause optional when unfolding if. Is there like a... I can't remember. -w colon no experimental. Ah, that's nice. I mean, I might just take that. I might just take that out. I don't really need a find pattern there, but I wanna stop now, and I don't want to leave it with warnings spewing everywhere. So okay, so now hopefully disable find pattern warnings in test script. All right. I got quite a lot working. I'm really happy that float expra is done. Yeah, I'm glad to move on from that. That was a real. I don't know if I would say challenge. It was a slog. You know, there was a lot of it. Yeah, the stack is not empty at a point where I was expecting it was going to be, so that's going to require some thought. Let's see it pass on GitHub. Convince ourselves that the WebAssembly spec hasn't changed since the last time we ran the tests on CI. All right, excellent. Well, that's very good news. Okay. All right. Well, I'll say bye. Thanks for watching this, as always. I really don't know if anybody is watching this, but given that you are hearing these words, you are watching it, so thank you very much. I hope you're finding something in this interesting. I'm really enjoying this. I mean, the project is never ending, but it's very satisfying when I make some progress, and I feel like I made good progress today. So that was a good session. All right. Well, I'll see you next time. Thanks very much. Bye bye.